All right, let's make sure my microphone's working here. Looks like it is, so that's good. Looks like this is all going. All right, good. We'll get started here in a minute, guys. We're gonna talk about technology, just general topics that I've lectured on before with you guys, and we'll just talk through system stuff and yeah, just generic. I haven't been on for a while, so we're just going to talk through a bunch of older presentations probably. Let's see, we're doing this one here. Probably walk through. Let me find another one that's good. We did about half of the networking primer the other day. We never finished that one completely though. We might pull up Socratic Linux a little bit. That might be fun too. People tend to enjoy the Socratic Linux when we get to it. So we'll figure out if we get that far today, but let's see what we can get to. So, all right. Pull myself up here. I have not streamed in a few days, so you guys should see me, you guys should hear me. Should be good. And let's fix the Twitch side of things real quick. And just say Orange Hue, how's it going? Yeah, we're, just getting on here a little bit. And I'm going to talk a little intro to cloud computing. We'll walk through some stuff there. Maybe we'll even go deploy some stuff out in the cloud. I don't know. I don't really do a lot with, it's actually funny. I work a lot with clouds, but it's NOAA. So it's National Oceanographic Atmospheric Agency. But I'm not working directly with the actual, cloud concept. So we're going to talk about intro to cloud for people that just, maybe you're like trying to get into the cloud, trying to figure out what's going on with it. So here's my overview. What is cloud computing, right? Most people probably think that's kind of a generic term, but it's actually pretty well defined. It's actually highly defined by the NIST, which is the National Institute for Standards and Technologies, right? Or technology. And then we'll talk about the cloud deployment models and the cloud service models. We'll talk a little bit about what we call, so there's three major component categories that we'll talk about there. We'll talk about security and service providers and how you decide which ones you want to work through and just all that kind of stuff. If anybody cares about my background in that, I'm a solutions architect pro with AWS, but I don't do that work really anymore. So I hold their certification, but I don't really do much with it. So, and there's Fisherman. He's actually also holds a bunch of the same certs and more than me. He's
months. Let's go.
Yeah, I think Fisherman's actually at I don't know, man. What are you at, 8 or 9 of the AWS certs? I was just looking at them again the other day. I wish I had time to finish all of them. I've been so focused on the dissertation and stuff. So Orange Hue, it's funny. My company actually did some research on that. God, that would have been 2021 probably. And we used the Azure platform, so we didn't use AWS when we did that. And honestly, the cost of the cloud for the same type of compute work that we were doing, because of the fact that it's a constant stream of compute work and not burst, and also it's heavily like network heavy for a lot of the parallelized file systems and stuff like that. We found that back then it was about 10 times the cost to be in the cloud compared to doing our same. So we were using the current model flow of what's called NCEP, which is part of NOAA, and NCEP, if anybody cares, National Climate and Environment Prediction or something like that. We're the ones that every 6 hours run all the data models for the whole planet. Everybody gets data from NCEP and NCEP inside of NOAA, but that doesn't really matter. Anyway, so we're going to get to cloud service models, how they work, what the formal definitions are. Guys, there are so many then gray areas inside of there. In fact, I tell people, I've been saying this for like 4 years now, I think they need to revise this and put function as a service on there as well, but here we are, we still just have these ones. What did Fisherman say? I don't know. I think 9 with cloud practitioner. I'm surprised your cloud practitioner lapsed, because I didn't think, because when I got my practitioner and then I got my solutions architect associate, it redid it. And then when I got my pro, it said that it redid both of those down the stack. So if you have, because I remember you got your pro just before I got mine, Fisherman, I'm pretty sure yours should have refreshed under there. I think, I'm actually wondering, because I think you got those first ones before you went to work where you work now. So I wonder if you did it on a different one Yep. That's exactly what I was just thinking. You just said it. Yeah, yeah. I thought like he probably did it under the one. I'm in that same boat. Like if I want to go take them, I don't have. I was working at AAA at the time, and I did it all in my AAA email. So I'd have to go and get it pushed over back to me, anyways. I mean, I still have like the Credleys or whatever, so like people know that I have my certs. But there's that. Um, I actually like that. Kay Flanagan said, "What is the cloud? Other people's computers." I agree with that a lot. And I have a shirt. One of my family members years ago got me a shirt. One of my brother-in-law and sister-in-law, over the wife's brother, if anybody cares. Um, they saw a shirt out in public, and it just said, "Dad, what are clouds made of?" And the dad said, "Linux servers mostly, son." And they bought that for me. They're like, "Scott's always talking about that Linux crap. Let's get that for him." So I have a shirt that says, "What's the cloud?" In fact, when I first presented on this here, I had that shirt on, but now I'm just wearing one of my black Duluth shirts that have like these long fit type stuff. So, Leith, how's it going? And we're not working too hard today, right? I'm still working on dissertation. The wife's birthday was 2 days ago. Thanksgiving was yesterday. Some of you guys that hang out in our Discord, our Discord is almost to 4,400 people, so it's pretty popping in there. But I was going to show you guys, if you go to our Discord, we had like some off-topic discussion today, and like you can see what I did yesterday at the party. I had these just like some of you guys remember the little hats that you made when you were in grade school. So I had this stuff for the kids to do, and then I took pictures of all the family wearing all their hats. And actually, one of these, did I take the picture before? Oh, the wife did. There were these little pom-poms, so the wife did that. I imagine those are color-coded. I'm way too colorblind to tell, but I think they look like the right colors. So, anyway, so there's that. That's all in the Discord for people that want that kind of stuff. But we'll get into this a little bit. We'll talk through the things. I'll tell you guys where I would go to learn more, because I know some of you want to get into the cloud. And then, Leith, what'd you say? It was moved to second round and offered an interview. Nice. Boom. Cloud engineering. Leith, you take over. I'll give you a call. You can teach this. You can show all the guys this stuff. That's awesome. No, that's like just getting in the industry, baking in for a few years, and then being able to go. Wait. I meant. Oh, okay. Did you guys see that? You guys saw that, right? It said bacon, BACON, like making bacon pancakes. Don't get me started on that, guys. The wife gets so mad at me because I'll just start singing Making Bacon Pancakes, which was, of course, Jake the dog. Some of you guys know who that is. Ops that I just joined, I used to have a lot of certifications, including professional level Cisco and most of AWS. Now they're all expired. You know what? Ops, or OSP rather, I should call that Open Shortest Path FISA. That's funny. I used to love the grind too for them, but then like, I got off the grind probably about 2 years ago, but I had ground out a bunch of certs and stuff, and they're all up in the search channel and stuff like that. But no, definitely congrats to Leith, because I know you had been looking, but also Leith's been around a long time with us. So also apparently saying the name Leith is bringing out my speech impediment, so I'm gonna stop doing that. I haven't had that speech impediment since like second grade. They worked on me a lot to fix that one. But then I start doing that name and it doesn't work very well. All right, so I said, what the heck and heck are these, right? I love that. I love that little animation. All right, so what is cloud computing, right? And this is actually, again, when I first did this presentation, I had the shirt on. But, you might think, right, like generally speaking, you might just be like, well, people say cloud. And here's why probably in some people's head it's kind of like that. Is that when I'm an engineer, right? If I'm drawing a draft and I'm giving you guys, let's say I'm trying to give somebody in a 30-minute meeting this, basic little drawing of what I'm going to try to build, maybe a proof of concept, minimum viable product. We're, talking back and forth about maybe some schema of how we're going to build out a few Linux servers, and then where we're going to put, the storage and all that kind of stuff. And I just bang one of those out real quick. If I were to draw something for you guys, I mean, we pull up Excalidraw right now, right? I pay for Excalidraw, so I think it's such a good tool. But if I were to draw something out for you, and then I were to put a cloud over here, typically that cloud means it's not germane to the conversation. And that word germane means it doesn't really matter, right? You say, well, what's going on over there? And I go, well, it could be a little of this, it could be a little of that. If I were drawing in our data center, a cloud would be like, oh, we might use AWS, or we might use Google Cloud Platform, or we might be using Alibaba. I don't know. That's not really germane to this conversation. Another way people like to say that is it's orthogonal to the conversation. It doesn't really matter, right? That's how engineers will talk, so you'll hear non-germane and orthogonal, and that's what they mean. It doesn't really matter, right? So where I'm going with that is, as engineers, we're almost conditioned. If I see a cloud, I think it doesn't mean anything, or it means don't worry about it right now. But that's not how cloud is. Cloud is a very well-defined conversation, and the NIST standard is 800-145, I believe. So we should see it right here, 800-145. I'll drop this for anybody that wants the link here in a second. It's actually the funniest thing. I love showing people this because in general, government publications work like this. I'm going to link this to anybody that wants the government publication. Boom. Right? Because you can pull up on your own machine. This is a open cloud standard, right? It's the standard. And my favorite thing to show you guys when we talk about like a PDF like this PDF is 7 pages long. But the first 4 pages are them patting themselves on the back so hard before they actually get to the start of the definition. So, we're already up on page 6 of this doc. Now we got the essential characteristics, the service models, and the deployment models. Those 3 things are what I'm going to kind of break out for you guys here in a little bit. But I just want you guys to see that this is very well defined. You can go find that. You can reference that. I'm going to probably be referencing that in some of my research that's coming up, for my dissertation that I always allude to and then never go work on. But again, it may come to you as a surprise that cloud computing is very well defined. And cloud practitioners and people that work in the cloud often, which we have a few of them here, they probably know that there's even more classifications, but at a high level, these are the things. There's essential characteristics. All cloud will have these. There's service models. You can pick from those and use those different service models. And then there's deployment models, which is how are we going to, how are those essential characteristics going to exist? Am I going to own all of them? Are somebody else going to own all of them and then share them with us? Are me and a group going to get together and share some of them? Are we going to be in a hybrid model of those? That's what the deployment models are. But the essential characteristics will exist in all of these. And here's the essential characteristics right here. You'll have on-demand service. I should be able to go and provision within reason and typically within a set of published parameters anything that I can give to myself to use without requiring some kind of human interaction. So I can go pull up my AWS console right now, or I can access it over, Bodo 3, which is the Python library, and Ansible needs that to be able to communicate up. Or I can use Terraform, and I can go and I can just start deploying EC2 instances out there. And there's a bunch of things that are already parameterized, and I don't have to assign them. Like I'm using a default region, and out in that region I have a VCP, and then in that VCP I have a network already set up, and those things are maybe defaulted, or sometimes I have to give them. It just depends. But the point is, I can do that without talking to anybody. And all interactions of this on-demand service, no matter how you do it, are always done via API. It's a very important thing. I tell my engineers this all the time. Even if you're at a console, the console is making API calls for you. If you're using an SDK, a software development kit, you are using, it's still using APIs. And if you are using some type of command line, like you're using PowerShell for up in Azure, or you're using their Azure CLI, that you're gonna be running, there's an API call happening at some point. So knowing that, it's very important to know how your communication happens, right? Like, so if I log into a console, typically, I get into like a web portal console type situation. That type of access is typically a username and password. And then once I get in there, all the API calls are happening behind the scenes via keys. If I'm using AWS's like an SDK, then now those are all your keys, right? You have 2 types of keys. One type is never seen again once you first generate it, so you need to go store that somewhere. Typically, we store it in like a local vault or something. But the point is, I can go make stuff up in the cloud whenever I want, right? Now, look, guys, there are things in here that will keep you from getting a $13,000 bill right at the end of a month. Like most AWS instances, they'll only allow you to put, here's some very simple ones. Like you can only put 50 tags on a resource. You can tag a resource with all kinds of key value pairs, but only 50. That might even been upped in the last few years, I don't know, but we can go reference that if we wanted. I can only have 5 virtual cloud VCPs or whatever they are. I'm drawing a blank on them right now, but I can only have 5 of those in any one region at a time, right? I can only deploy so many S3 buckets at any one time, right? There's all these types of rules. So it's not 100% like I can just provision everything in their resources. They're still within reason and limits and stuff like that. But the point is I can go and do that without talking to a person. And then there's broad network access. I should be able to talk to this and access it from anywhere, any general network. I might be able to use other platforms to get in there, right? And then maybe use mobile or something like that. But the point is I can get to it from anywhere. There should be resource pooling, or what we call economies of scale. Economies of scale means that, like AWS can buy 100 servers for, $1,200 per server, whereas I could buy 3 or 4 of those servers, but instead of being $1,200, they might be like $4,000 each. They get tremendous economies of scale, and then with the resource pooling and carving, they can give us more resources at a cheaper cost than I could go and allocate them myself. Now that's even without all these other things, like when you do AWS or Azure training, they teach you all these other things about that and this kind of stuff, but that's not really too important right now to know. But the point is that they have resources pooled, and then you are sharing tenancy on those devices with other things. That's a common term. Do I see the word tenancy here? No. But when me and somebody else are both tenants on the same server, that becomes important. The reason it's important to know that too is I should be able to, on most of these cloud providers, have my own server if I want to, and then virtualize on top of it. But understandably, that should cost me more money because now I'm renting out the whole server. And companies do that for, there's a few very specific reasons, but one of them is for like FIPS compliance. I need to be able to have compliance and not be sharing memory space with any other servers from any other companies. Sure, right? Rapid elasticity says that if I have 3 of a resource, then I can make it 10 very quickly. I should be able to scale, and there's 2 ways we scale, right? We scale outward or horizontal, and horizontal is just standing up more servers. That is very useful for web servers and application servers, right? Like a web server can just be 3 web servers, static content for the most part. Behind a load balancer, you add 7 more servers, you just add more paths for the load balancer to go back to. Once it gets a good health check to any of those nodes, then it makes that link active, and you can have a whole bunch of connections and a whole bunch of communication, right? But then there's another type of elasticity where it's not just horizontal scaling, there's also vertical scaling. So things like databases. A database, I often tell, like, especially as you get into building database, because I've built hundreds and maybe not quite that, not thousands yet, but hundreds of servers over the years for databases to be on. And let's say you had a database server sitting here and it was using all 512 gigs of its RAM. Well, putting another server next to that with another 512 gigs of RAM will accomplish nothing. It'll give you nothing on most modern databases. What you have to do, instead of horizontally scaling those, is vertically scale it up. You've got to give that database more memory. Databases are, in some ways, a lot like if you're filling a bag with water and that water's like trying to find the lowest point and like spreading the bag out. Databases are the same way with memory. They will absorb all the memory that they can have. They're like Ron Burgundy. He'll read whatever's on the teleprompter, right? Or there's an old saying. There's a rule called Parkinson's law. Parkinson's is also a disease, but there's a rule called Parkinson's law or Parkinson's rule, which is work will expand to fit the time allocated to it. By the way, I'm proving that literally every day with my damn dissertation because I have shit that's due that I just haven't done yet. Either way, neither here nor there. And then measured service. If I'm going to be charging you for compute or virtual CPUs or memory storage or almost always free into the cloud, but then cost coming out of the cloud bandwidth, if I'm going to be doing that, I have to measure it, right? I have to track it and quantify it in some way. So that kind of makes sense here, I think, for probably most of you. So these are the essential characteristics. These are things that have to exist for us to really consider it the cloud. There are a lot of things that perform some of these, right? Like virtualization, right? I have all kinds of virtualization in my home lab environment that we could look at, but that's just resource pooling. And maybe I even have broad network access. And then I have some functionality for some rapid elasticity, but I'm not really measuring the service, and it's not really on demand for others, right? People can get in and get to our labs and stuff. It's not really on demand. They can't make their own labs when they're ready. So my home lab environment while virtualized, and while some of these things does not meet the essential characteristics to be called like a cloud environment, even a private cloud. I wouldn't even call mine a private cloud. So let's look at those real quick. So, we'll get to the service models and then we'll get to the deployment types. So service models are the way that we utilize those things in the cloud, right? So we have typically something like software as a service. That's capability provided to the consumer to use the provider's application running on cloud infrastructure, right? So that's software as a service. Software as a service tends to be the least responsibility for me and the most responsibility for the provider. They're going to have the application, they're going to have the infrastructure layer, which in some ways they always have most of the infrastructure. They're going to have the server. They're going to have the middleware layer. And me, I really only do two things in there. You guys want to know the only real two things I do with a software as a service? I configure the service and I load the data in. Those are the two things I do. So that'll become important here in a second. Platform as a service lets me have a little more control, where typically they will deploy or give me some type of platform, and that platform would be a Windows machine, a Linux machine, I guess Mac. I don't know. I've never tried using Mac in that kind of concept, but whatever this thing is, right? Typically Windows or Linux, let's say. Those are the only ones I can really speak to, and I can then control the platform within some reason. But do I really know or care what maybe is going on with the VLANs and those kind of things? No, not really. I'm just I'm given the platform, and I can maybe reset the server if I need, and those kind of things. Things that I never see in software as a service. I typically just see like a web front end for these kind of things, and then I control it that way. This I can actually SSH into the box because I own the server. And then the most control that I get and the least responsibility that they take is infrastructure as a service. They're still running the back end, whatever their hardware virtualization is, their hypervisors and stuff. But then I can come in and I have control over, in this case, typically what we call the SDN, software defined networking. I can deploy certain ranges, typically a /16 or smaller network range. So 65,534 total usable addresses. That's pretty good. And then less as you subdivide it down. But infrastructure as a service, I have a lot more control. I may even have control over DNS in here. I typically do. And I may have DHCP control, but not in AWS. Like AWS, you can't do some of the things that you might want to do out there. So Juan said cloud automation so freaking boring. Everything is abstract. I remember when engineering used to be fun. Yeah, so it's funny. I actually still teach a Cisco, basically a CCNA course. It's not called a CCNA course at the college, but it's all the components of CCNA. And then the book is a CCNA book. The labs are all prepping my students for CCNA. It's just, we do I would say 50% of what you need to pass a CCNA in this one course. It's an 8-week course. It's pretty good, I think. But where I'm going with that is, yeah, my students touch all of the individual components of touching an actual Cisco device, setting routes, setting networks, setting all these things that we really often don't do anymore. So, I got my CCNA back in 2002. Yeah, 2002 is when I passed mine. And actually, it's funny. I got my, I don't have it up here. I have my ISC squared card right here. So I got my CISSP right there, but I don't have I thought I had my CCNA up here somewhere on one of my monitors over here. I have these platforms that my monitors sit on, and I was looking. Actually, I have something else interesting over there, but you guys don't want to hear about that. All right, platform as a service. So these are the things, right? And this is a lot to try to remember, because this is very often when people just give you blocks of text like this, it's hard to remember stuff like this. So what I like to show you guys, we'll get to deployment models, and then do I come back? Hold on. Yeah, here. I really should change this around. So we'll call each of these high level, and then we'll come back, right? So we're gonna, again, wall of text, not super good for memory, but in a second here I'll show you how to remember it. So deployment models come like this. There's private cloud. That's me doing all of those essential characteristics. There's community cloud. Me and my buddies get together and do all of those essential characteristics. And then there's public cloud, where somebody else like AWS or Azure or Google Cloud Platform or Alibaba or Oracle Virtual Cloud, whatever these cloud providers are, they do it, and then I get those resources from them. Public cloud is by far the most common type of deployments that you'll run into. Community cloud is often like a HIPAA compliant set of doctors in an area or dentists or something. They have to be HIPAA compliant, and that is hard to do. Like we could all spend $1 million, or we could pool it together and only spend maybe 500,000 each and get a data center that does these things. Now, you might say, well, why wouldn't they just use a public cloud? Well, sometimes people have different requirements and maybe they want to do whatever, right? So there's all that kind of stuff. And then hybrid cloud is some I want to call it bastardization of all of this, but it's some area of this. And I will tell you, every organization I've ever been in is in one of three states. They are either on-prem and moving out to the cloud more, or they're in the cloud trying to get shit working right, or they're in some state of getting stuff out of the cloud because they've had their costs too high. So those are like the three things that I always find. Raleigh said it's not always about efficiency. Keeping this confidential data apart is often important. Oh, 100%. Yeah. Sometimes you're spending a lot of money just to have your own stuff separate. Yes. And the government's a big part of that. There's public cloud, but then there's like gov cloud. And gov cloud, I've worked on that probably like 10 different times in my life, different gov cloud stuff for the federal government. But also there's Chinese government stuff. There's don't quote me on if there's European government stuff, but there's definitely stuff that's in compliance with GDPR for Europe. But for sure, I know that like Azure has their China version, which to even get over there, you have to have permission from the Chinese government and that kind of stuff, right? Or some kind of writ that says that you can do it. So these are models. Let's look at them here in a way that we can remember them. Are there common deployment parameters being added to support resource optimization? Can I get cheaper cloud supplier if I don't care, as long as it meets the average compute rate? Yeah, Orange, there is, yeah. I don't get in this. I don't get into like optimization stuff, but big time. There's is there European sovereign fishermen? Fishermen, look at the question right above, and it's like, yeah, Orange, there is, so in AWS, right? They are trying to fill up their compute but not go to the top, right? It's kind of like this. I always tell you guys, when we look at compute in general, when you look at any one slice between 0 and 100% of a utilized CPU on any server, in that 1 second, if you're using 80% of your CPU, let's just say you're really cranking it out, that other 20% is lost forever. So a company really wants to be efficient. So Orange, to that point, AWS on their back end are tracking their utilization levels across all their data centers, right? And there's a pool of resources that are they're called the God, why am I blanking on this right now? But basically, you bid for them. They're spot instances. That's what they're called. And there's all kinds of ways to do spot instances. But basically, yeah, you can say, hey, I want to average this much amount. Maybe I need 1 or 2 servers up. But when it gets to a cheapened price, I'll bid to open up 1 or 2 more servers and get more processing in. Orange, there's absolutely all kinds of models for that. And then there's all kinds of things going on within your application code where, so when you're using an EC2 instance, and I show this in other things, but you always have this metadata that's tagged to the instance. It's on the 169 like internal address that the system can hit for himself. And what happens is your system gets alerted on a spot instance with like 1 minute to shut down. So if the cost has risen more than what you've allocated, you get like a minute or two, I think it's a minute or two right now, for your application to stay up before it turns down. So yeah, it's exactly like a market rate. It's like the fluctuation of how much demand is driven, and that's by some back end thing that we can't see. But you can absolutely bid on those resources, Raleigh, 100 or Orange Hue, 100%. You can absolutely bid on all that kind of stuff and see. Yeah, so people and we'll do that with like batch jobs and stuff. And then there's spot instances, but then there's also where like you'll say, okay, I'm only going to use up to like this percentage, because you can save like almost 80 or 85% of your costs by doing spot instances. But you can also have some where you go, okay, but if it goes up by even over 10%, I'll keep paying it so that my system has longer time to shut down, or there's all kinds of stuff that you can do with that. And that's a different talk, Orange Hue, but that is definitely valuable. I have a bunch of stuff too up in our Discord, right? All this Discord stuff. We have old like presentations, and or maybe everything didn't make it down in presentations. It might be up in certifications. But if you go look for like AWS Solutions Architect, you'll see old presentations that I've put in there. So this was like my old cloud practitioner stuff. It's been updated, but it's still a little dated because it's from 2023. But I have old AWS Solutions Architect Associate and Pro from when I got done studying for it and then when I went and passed it, and I kind of released all that for everybody. Juan said, "Did I get CISSP pin?" I have a CISSP. Like I have. Well, okay. So if anybody ever comes to my house, they're gonna look around my office and be like, "Man, this guy really likes having shit up on his walls." My wife loves putting all my stuff up. Like I have a whole thing over here on the left of me, that's like all my old Army stuff, and then I have my CISSP and my CCSP right over here, and then I have all my college degrees over here with a space up top for when my doctorate gets finished, probably early 2027. Anyways, where I'm going with that, I have a pin, but I don't know where it is. It's in it's in one of these. I have like a whole closet full of stuff. Like anything my wife can't put out on the walls, she puts in my closet for me in my office. So yeah, I do have a pin somewhere for both my CISSP and my CCSP. So CCSP is much more related to the things we're going to talk about in the cloud here in a second, but the security stuff for sure. All right, so let's keep going a little bit, and let's look at these. So all the things I just explained, big walls of text that come directly from the NIST standard, it's hard to internalize all that. So let's go look at it. Right, this is kind of what a private cloud would look like. If I had a private cloud, my infrastructure would be possibly on-prem somewhere, maybe out in like a rack hosting. We used to have a lot back in the day. There used to be a lot of like rack hosting, and then some company would just basically plug stuff in for us, or we would have our own cage and we would go in there. Yeah, Raleigh, I'm the same way, man. Like my certifications are so much less important to like what I can kind of talk to, but some jobs, some government stuff does require it. And like even because I work kind of for a smaller company, some of you guys know I work for a company called Redline, and when we put in for government bids, sometimes you must have a CISSP on staff. So I check that box, right? Or CCSP. Sometimes it goes back to this DOD, it's like 8570s. There's a standard for it. We could look it up if we want, but it's basically like you need so many people certified. Like there's this one of the projects I worked on a lot. Well, actually, I still work on it sometimes when they need me. You need to have a Security Plus. Just across the board, you need Security Plus to work for this government installation. But I have a CISSP, which for the government counts as the higher standard, so then it doesn't matter. But for all the other guys, a bunch of the guys on my team had to go get their Security Plus or whatever, which is fine, right? The company pays for it. You just got to go study on it. 2010 with an OpenStack. Yeah. I've never run OpenStack. I've heard about it. I've like played around with the edges, but I've never deployed that anywhere. I've deployed OpenShift quite a bit, but not OpenStack. And I know they're different. I just don't know much about OpenStack. Besides, it was bare metal cloud. That's the only thing I really know about it. So private is some version of this, but you own it, you run it. Okay. Then community cloud is, again, you own it, but typically with a couple of other organizations of like-minded practitioners. So we might have, maybe in the Phoenix area, some dentists get together and they all have to adhere to HIPAA standards, and they want to digitize a bunch of their records and then be able to maybe compare some stuff. So a good buddy of mine came and talked to the group last month, and he was talking about he works for it's a radiological company. I forget their name. I wouldn't say their exact name anyways, but they do basically chest x-rays. They do other types of x-rays too, but basically chest x-rays. And then the doctors look at it, and doctors have to look at it. But they also, this company, like some kind of radiological partners, they have a whole bunch of different organizations, and they got together and they said, hey, this AI stuff is really good at like looking at a person's x-ray and saying, well, there's a little fracture on the rib right over here, and maybe they've got a hole right here in something, or maybe this muscle looks torn. Whatever. I know muscle doesn't show up well on x-rays. That's about all I know. But they can look at this thing, and then a person will check off and go, oh, yeah, there is a little crack on the rib there. I might not have missed that, or I might not have seen that. So they have this AI project that they've done internally that has, I think he was telling the group the other day, so some of the guys might remember this better. We had like 20 or 30 people come to his talk, but he was explaining to people, they've gotten like the time, like they used to have, because it's hard to get a radiologist to go read at all these different hospitals and to have all that kind of stuff. And his company's like all over the U.S. I think they're even moving outside the U.S. So they have this little AI that helps them to read. They built it internally and fed it all the data. And then they check it, right? They always have a human check it, right? You got to have a human read it. That's rules. But it helps lower the cost of time and all that kind of stuff. And I thought that was kind of cool. And they are running, in some sense, their own little community cloud. They're also running some private or public cloud stuff too. But maybe you had something that was so cutting edge that you don't want to be out on a public cloud. You don't want to risk that. And some organizations do have, there are government requirements for that, and there are some organizations that have their own internal requirements, like, hey, we're never going to do this out in the cloud. I don't care how much the AES 256 standard and all of our key encryptions and all that stuff, I don't care. Not doing it. We're never putting this data out in the cloud. And that's, some organizations make that distinction, and it's their data, right? They should do what they want, or they should do what's best for them with whatever security they need. All right, so public cloud is, again, this is AWS, Azure, Google Cloud Platform, Alibaba, Oracle, and then a billion other ones, right? But anybody can use the resources. Oh man, I mean, I'm trying to think of the other ones that are like, there's what are the ones, there was like a nerd one that we were looking at last year around this time where they had ridiculously cheap deals for you guys to get like 2 servers out there. I want to say they were like $2 or $3 a month, and then you would lock in that price for like 2 years, and you spent $50, and you had these 2 servers that you could just go beat up and reset whenever you needed out in the cloud. And some of the guys bought that. I remember it was pretty cheap. But it was Nerd Rack or Nerd Host. What was that? Does anybody remember that? I don't know. Probably I don't have the memory I used to. I think it was called Nerd Rack or Rack Nerd, something like that. Anyways, public cloud. Hybrid cloud is some variation of it. Or some versions of maybe a private cloud, a public cloud, some hybrid, right? We have some resources over here, some resources out here. This is probably the most common. In fact, I did a talk years ago for my company when I finished my Solutions Architect Pro, and it was called like quick wins to get into the cloud. And it's like, how can an organization that wants to do more stuff out in the cloud and save themselves from having a data center kind of do that? Now, for my organization, Redline, we still have a data center. We have kind of a small data center, but we do high performance compute stuff. So we physically touch hardware all the time. Like I go in data centers still sometimes when I'm needed. We physically build and run and deploy things and do all of these other things. So for us, it does make sense for us to have our own hardware as a company, even if sometimes it's a little dated or whatever. But the things that we do, they're very valuable to us, like the operations still in a data center. But not everybody needs that. All right, so anyways, hybrid cloud. Again, organizations are typically moving out of traditional infrastructure up into the public cloud. They share, you get some VPN set up, you get some data moving up into the cloud. Maybe you find that, some of those batch workloads are really easy to run up in the cloud and really cheap. You get a tremendous amount of what we call economies of scale. We get a lot of what are called operational costs now. So what used to happen back in the day, I'll pull you guys up something I did long ago for a company. Hold on, let me go find, let's see. Mezzanine. I need to find this. I have to go up one. Did this for a company long ago, right? This company called Keras. And I did this deployment for them, right? This was back when I used to work for them. And just in this deployment, right, there was a storage need, and then when we got to the building, right, we had to go buy this server. I just really wanted to show you guys this, to buy this server. And that server took a few weeks to come out to us, right? Took some time to get out to us. And then once it finally got out to us, I had to go load up all the disks. So that took some time, and then I had to build the operating system. It was sent to us 7 back in the day, but I rebuilt it with my own operating system. Still sent to us 7, but not the one that shipped, right? Hardened it myself, put it out there in the rack, and then I built one also in Phoenix and shipped it out to Texas. So we had these in 2 places. Had Gluster built between them, right? It was a Gluster configuration and carved out and all that kind of stuff, right? The reason I show you guys that is because the time it took me to order that, get it shipped to me, 3 weeks, deploy it, let's say I did it fast, 3 or 4 days, let's just say. And then, but that green, we picked that green because we wanted the most obnoxious color. We could paint it, they would paint it any color we wanted, and we got the most obnoxious, gross looking green we could. So if anybody's wondering like why that was green like that, we picked that. That company, 45 Drives, they still build Storinators, and they do a lot of big storage projects and stuff. And they're an interesting company to keep an eye on. So Storinator reminds you of Trogdor and Burninating. Yeah. They have a Destroyinator as well, but Storinator is their big server line. So anyway, so I built that. It was like $22,000 in each location, so it was like $44,000 project. But then it was $44,000 project and about a month wait before we even got it up. And then we started to move projects over to it and that kind of stuff. And it, I forget the exact, it was 88 terabytes in both locations. And then it was at network line speed. So we did that to have just a big storage, and that was pretty big storage in 2015. So that was pretty good size for, especially for the money, for the 22,000. And then have it mirrored, and you could always get at your data, and then have everything point at it. There was I didn't show everything, but there was Samba shares so that the Windows devices could connect to it, because a lot of our lab instruments were Windows devices. In fact, they were Windows XP, if you're being honest, because Windows XP was still built into a lot of lab hardware back in the 2015 timeframe. Where I'm going with that is, there's a tremendous amount of cost. Like if we were in a rush to get some product to market, we were not in this case, and this was an internal thing we were doing. That month is a long effing time. Whereas like we could talk right now and say, hey, Scott, I want to build like an API out and have that API go do some function on like an EC2 instance. And we could draw that up here in a few minutes, and we could deploy that to the cloud and have like a minimal viable product here in a few minutes. Like literally while we're sitting here, I could just have my EC2 instance up, and we could be connected to it and doing whatever we needed. So that is like, if I needed something quickly, the old model, and by the way, $22,000 up front for the two things, so $44,000 total. That was all up front from the first day, right? Because we had to buy it. Maybe there was a little bit of a purchase order and some time in there, but before it ever went live, there was this big long time. Whereas that same 88 terabytes in the cloud back then, by the way, we weren't filling it up immediately. So let's say we only needed like 4 terabytes in the cloud the first day. That in an S3 bucket, even in 2015, was, I don't know, if I had to guess, less than $50 a month. So where I'm going with that is like, I'm going to have to switch out that hardware well before that operational cost is ever even going to touch that. And I could have that data pushed up there today. So my point is like this idea that like, cloud does other things besides just save you some money. Anyway, so let's look at like the service models. Let's go back to that concept we talked about of infrastructure as a service, software as a service, and platform as a service. Infrastructure, platform, software, right? This is kind of the model. This is kind of the model you'll see. In traditional IT, I own everything. In my home lab, I run everything. I go put it in the rack. We do rack stack, right? Space, all that stuff. I do all the cooling in the other room. I do all the electrical. I slide everything into my rack, which is about half stack. So it's, I don't know, probably like, if I had to guess, it's like probably 20 U or something like that. Each U is 1 3/4 inches, right? But here's traditional. You do everything. You do your networking, your storage, your servers, your virtualization. If something's wrong, you come in and you work on it, and it's all yours. But in infrastructure as a service, this is what's delivered to me as a service. There's networking, storage, servers, virtualization. I don't even know where the building might be in AWS, right? I might know that it's like US West or US East 1, which there's that old joke, stop deploying in US East 1, right? That's where most of if you go look at like the old failures in AWS over the years, a lot of them start there. Not all of them, but a fair number of them. You can go look. AWS has all their failures out there. You can go see all of their customer failures over the years. They have a dashboard for them. We have it up in our Discord somewhere if anybody wants it. But all the way up to an operating system. Then this is split because sometimes they'll deploy the operating system for you. They'll have like ISOs and maybe a location where you can hit a button and deploy one. And sometimes you bring your own, right? Sometimes this is build your own system. They just give you maybe like a web console or a IPAM, right? I think that's something not IPAM, IPMI, right? You just have an IPMI interface and you can load an ISO from your machine and build a machine from scratch or something. Then maybe you can save that locally or on some storage you have. But you then put the middleware. So middleware will be your, maybe an Apache server and Tomcat. Your runtime will be Java, right? Maybe you run Java on top of it. You will load your data in your applications, whatever you're running, whatever you're building, your stuff. Your data is obviously important stuff that you load in, like your databases if you have them. And then your applications are whatever code you have that interacts with that, right? This loading of this, in fact, in all of these areas, you never get away from having to be secure up here. And when we do the pizza as a service, I'll explain what I mean, the difference here. Got platform as a service, it's just more of them. And then software as a service, you really just load your data and configure it. That's all you do. And typically with software as a service, you just have an API. Here, you typically with platform as a service, you don't always even get the ability to maintain your operating system. Sometimes you do. Sometimes you can still SSH in, but you load your data and applications. Okay. So these are kind of where all these things come from. These are the service models. Sometimes it's useful to think of them in this, and there's like 100 of these on the web. So this is pizza as a service. If you make it at home, everything for pizza is on you. The cheese, the toppings, the tomato, the dough, that's all on you. You got to heat it up. You got to put it in an oven. You got to do whatever you're going to do with it. You got your sodas, your dining room table. You're going to clean it up when you're done. Everything's on you. But as we get over to infrastructure as a service, maybe this is a take and bake, which, for the record, I have still never in my life done this. Like, you turn the oven on and to pre-bake, and then you drive somewhere and pick up a pizza and bring it back. I guess this is really good. I've heard good things about this. I've never done this. But think of who's responsible for the rest. They'll put the pizza together for you, but you got to fire it up and get it ready, and then you still got to have the dining room table and this and this. Over here, pizza delivered. They're going to do all of that. You still have to have a dining room table and some soda and some plates and that kind of stuff. Maybe they even bring plates to you. But the point is, platform as a service, more is on you. And then if you go dine out, you don't even want to clean the plates and stuff. But in all of these, who has to wash your hands? Have you guys ever been to a restaurant? I've never been to a restaurant in my life. Maybe there's a place this fancy where like they wash your hands when you come in. I haven't seen that. Although I do like to point out when I first talk about this, there's one funny thing about this to me. Anybody here remember probably in the last, this probably would have been like 2017 or 2018. Do you guys ever remember out here well, it was in America. I don't think it was anywhere else. There's a company called Chipotle, and they had a whole bunch of kind of like this breakout of like people were getting sick. People were going to Chipotle, and I think it was even E. coli or something, but whatever it was, a few people got sick. So then the next time you walk into Chipotle, and it's always packed, right? The next time you walk into Chipotle, right at the beginning of the line, there was like a little thing you could put your hand under, and it would give you some of that, kill everything, kill 99% of bacteria or whatever on your hands. Because if you ever go into Chipotle, this is interesting. You ever go into Chipotle and you watch people order, and then you sit there, and if you were to take like 100 people that come in that Chipotle, and I only know this because I've done this, I'll just sit there and just kind of watch the people come out. Most of those people go right from ordering to eating. Very few people ever go and wash their hands. So where I'm going with that is like, this was kind of like them going, hey, fuck you guys. You're not going to say it's us when you nasty mother effers don't even wash your hands when you come in here. So that little thing at the beginning to me for Chipotle, that little thing right at the start of the line, that was always funny to me because it was just like, it was them saying like, hey, we're not taking responsibility for all you assholes getting sick eating our food. It's because you don't wash your hands when you come in here. And I just kind of thought that was funny. I'm the pot calling the kettle black because I don't think I go wash my hands often either. But I typically wash my hands all throughout the day, so maybe I'm being a hypocrite. But anyways, all right. So let's talk about some cloud security concerns. These are things that I think are valuable. Also, these come from, I guess, my authority as a CISSP or CCSP, but it doesn't really matter. These are concepts that are broad and kind of wide-reaching. When we talk about data in the cloud, this is actually, you do need to know this for your CCSP. We have a thing called the Cloud Data Lifecycle, CDLC or whatever. And as we create data, we then almost always at the same time store it. And then at some point we start to use the data. Then maybe when the data has been used enough or as we need to, we share it with others, maybe within our organization or other organizations. When that data has hit its useful life in whatever hot type storage it's at, we will then archive it down to cheaper storage because, right, we get more and more cheap storage as we have less need for access time, right? We save, there's economies there of savings. And then maybe at some point we destroy the data, right? Sometimes archive can be for, business comparisons or online analytical processing. We want to churn through data later to look for trends and those kind of things. There's all kinds of things here with archiving of data. But then typically we want to destroy the data in some way when it's went past its 1 or its 7 year either regulated or just useful life, right? And when we destroy data, we're saying this is no longer useful to us in any way, right? Well, if we step back for a second, when I used to run everything in my data center and I had physical disks and I was done with a server and I knew all the data that was on that server were no longer needed, I would take those disks out and I would throw them in a thing that looks like a little wood chipper, and it would chip those disks into little pieces of metal like this, that if you ran your hand over like this, it would not be fine. It would actually just cut the shit out of you. But I don't know that from experience. I'm just saying, I guarantee you that stuff was sharp. But it's useless. And I know that I've deleted all the disks that held all that data. And as long as I've done other things to properly protect my data, I reasonably know that data's gone forever. That's not true in the cloud, though. They're never going to send. Look, if I told Sending Grounds right now, I see Sendings in our chat right now. If I told Sending Grounds, he lives up in Washington somewhere, and I said, Sending, hey, I know you had those two like Western Digital 16 terabyte drives that were storing all my data. Can you go ahead and send those down to me, and then I'll delete them, and then we'll know forever that they're deleted? Well, what if he just copies the data and then sends me those and I delete them? Well, I don't know that his copy's deleted, so I have no control over that. Well, it's the same way in the cloud. So what we have is this thing that's called cryptographic erasure, and cryptographic erasure in and of itself is absolutely still not 100%. It's a pretty high percentage, like 99.999% sure that you're not getting at our data, but it's not 100%. And that's one of those reasons why cloud tenancy is so important. And it's one of those reasons why maybe F you guys, I'm never going to put this in the cloud. That is the reasoning. So cryptographic erasure works like this, right? I've got a data key to get at my data. And to get at my tasty data, which is locked like this, I need a key. And I'm going to open and unlock that data, do whatever I want with it. Then I'm going to lock it. I'm going to lock with the key. I'm going to lock it. Then I'm going to lock that data key next to it and put it next to it with another thing we call an encryption key. That's called envelope encryption, outside the scope of this, unless it pops up here in a little minute, and we'll talk about it. But that's at a minimum of AES 256. There we go. Encryption standard. And reasonably, with modern hardware, that would take you way too long to ever decrypt, right? That's the reasoning behind it. When I throw away that key and that data becomes an unusable lump and I tell you to delete it, then hopefully that unusable lump of data that's locked out there and that you've, honestly deleted for me, not stored forever, is now gone forever. That's what I hope. That's what cryptographic erasure is. But if I had something that was so sensitive that I couldn't rely on the entropy of time to protect me, 10,000 years at modern computing speed to protect me, and their honesty, then I can't put stuff up in the cloud. And some organizations, guys, won't do that. Because, by the way, what's 10,000 years of modern computing time? In 5 years, we may have some type of an advancement that makes that 74 minutes or something. That fucking somebody's gonna come along one of these days and download all this stuff from somebody, and they're gonna decrypt it in like 5 minutes, and they're gonna have every secret ever that was put up in that cloud. Now, that's assuming they didn't delete it, but I'm just saying, cryptographic erasure is the only control we have, which is why key management is so important. And when you go do security stuff, or when you talk about security with people, the way that we maintain and manage the keys is one of the most crucial parts. There's a lot of tools, though, right? You can trust the cloud provider, and you can allow them to do a key management system, or you can do what a lot of companies do, is they maintain their stuff locally, and then you start to get into things like HashiCorp Vault. Some of you guys have probably heard. You're like, hey, HashiCorp Vault, that's like this really popular tool, and it's like they're storing stuff here to be able to access stuff out there. How does that work? This and this. And I have a different talk that I do on HashiCorp Vault. I used to have their cert. I let it lapse. But Vault is a lot like, if you've ever seen a cop show, or if any of you guys were military, I was military. I was an armorer, actually, for a while there. When the way that an arms room works, or if you've ever seen, there's a show that does it a lot, and I actually like it for this, is if you guys have ever seen the show The Rookie. They're always like checking in or checking out their equipment. They like use that scene as like a common, like, God, probably almost, I probably watched the first few seasons with the wife. We just got so mad because none of them could ever hit they'd be shooting at stuff, and it was like, it was whoever it was always going to run away. And you're like, this is just terrible. You got to show them hit somebody. Like, you go watch the old X-Files, they land every damn shot. Those two were marksmen. But anyways, neither here nor there. My point in saying all that is, I'm getting far afield. an arms room. You go and you check things out when you need it, and then you go right along all day, and you've always got your service weapon on you, but then you check out, they would get their kits for the day. And you'll see this if you ever go watch that show, or if you've worked in an arms room, or if you've worked in any facility. They even do it on the show Monsters Inc. If you guys have ever seen the show Monsters Inc., the old movie, right, the little cartoon, and they go in and they like check in and they like check out their equipment. That's the same type of idea as like a HashiCorp vault. It is a like controlled environment for us to come in, present our authorization and our authentication, right, that we are who we say we are, get our resources out, and then go do the things that we need to with them. So, anyways. And they do all kinds of stuff on the back end. You play with all that. But anyways, I have, a lot of stuff with that. Data must be encrypted at rest. Data must be encrypted in motion. Data should be encrypted as used, right? And only decrypted enough to be seen. But these are the two places where data must be encrypted, at rest and in motion. So, so this is how data are created, and this is the data life cycle. If you take a CCSP, you won't see this on a CISSP, but you will see it on a CCSP. The types of questions they like to ask here I can never give specific questions, even if I had them all in my head. I couldn't tell you them. But I can tell you things like them. And one of the things that I liked that they did, because it shows that you understand the model, is they said, of these, and they gave you like create and store, and maybe use and archive, and destroy and store, and maybe share and create. But the first one was create and store. And they said, of these different these pairs that we just gave, which ones would most likely be happening at about the same time? Because if you understood, we create and store data at the same time. And sometimes we use and share data at the same time. But we would never use and destroy data at the same time. That doesn't even make sense, right? Not from this model. Maybe from other models it might, but not this model, right? So, personal keys for encryption at rest. That would be interesting. Yeah, Spongefire. It would be interesting. And there's always more models, guys. And man, there's so many things you can do with envelope encryption as well, which I don't think I have in here. Yeah, I don't have. This isn't my like in-depth cloud one. I have another talk that's like cloud security, and we can go into that if we want. I'm just hanging out because the wife is gone right now. And when the wife, she's coming back soon. When she comes back, I will have to get off of here. That's why I want to just hop on. I think I've only streamed like 2 or 3 times this month, so I need to get back on and talk to you guys. And we're going through old stuff. But if any of you guys want to see, any other stuff, you guys want to talk more Linux. I'm not really heavy Linux right now. We can get into Linux whenever we need. But we weren't really talking about it too much. Oh, Scram, yeah. Oh man, I got a thing from the other day. Hold on. When the wife didn't tell me she was back. Where is this at? I think the guys dropped it in here. Yeah, I was sitting here talking the other night, and I just saw, and I'm alone in my house, 2-story house. My dog Ranger's passed away, so I don't have alerting when people come home anymore, or I don't have alerting when other bad things are happening. And I just see this bun, like my wife's hair, bobbing over this monitor right here, and it scared the piss out of me. And that's what this clip is. Is me legitimately. I told her, I was like, "This is how I go. This is the heart attack. This is the grabber." Right? When I worked at Lockheed Martin, we used to call them grabbers. That's where you just grab your chest and die in your cubicle. We call that having a grabber. I was like, "This is how I go." The wife killed me. She scared me to fucking death. Yeah, she scared the piss out of me. It was bad. I did not know, because I don't hear in my new office. So my old office was directly over the garage. I knew when she came home all the time. I'm one room back in my house now, and I don't hear the garage anymore. So she snuck all the way up here, and she's like, "Oh, I thought you knew I was home," and I'm like, "Oh, my heart did not know." Anyways, all right, let's go. Yeah, we control no infrastructure in the cloud. That's an important thing. So let's go look. This is a topic. It's an important thing to understand. Defense in depth. We expect certain parts of what we do to fail, right? Like in my home lab, right? Let's pull up home lab, because I don't know why it's not. Apparently my system has rebooted since the last time I went in there. Let's go jump into my home lab, right? So here's my home lab. Pop this up here for a second. Jump into my local machine, right? And screen, right? So we'll hop into what we had available. So here's my different kind of local systems that I'm in. I'm in my Werewolf system. I'm in my jump box. This is my local machine. And then I'm over in the Bastion node, right? So I got these different nodes that I can hop into. And my jump server, so this Bastion node, P01 Jump 02, which is a replacement, and he's a CentOS 9 or a Rocky 9.6 box. He is a newer version because my older machine was getting too old. The cryptographic, everything that was going on was getting older, and we couldn't even maintain my older CentOS 7. Like the repositories were going down and all that kind of stuff. So we were getting older and older and unable. So this is the one that we use now. In here, excuse me, I'm the only user on right now, but we have a capability for people in our Discord that want to drop in their keys. You can actually come here and you can drop in your key. Fisherman has a little bot. So Fisherman Guy Bros around, he's got a bot where you go and you add your public key, and then it will connect you in here, and then you can log in as this user, and it'll drop you into our backend through a Bastion system that we've built. I show people how to build that Bastion system in other talks. It's not super difficult, but it is something that I've done for a long time for the government, right? But my point in saying that is, like, my SSH can be defeated. Maybe you can SSH into my system, you guess a password, boom, you get in. But then maybe I have SE Linux running. So now SE Linux only allows SSH to touch certain things because of this additional labeling that's going on. So now you can only touch certain things. Or maybe even you compromise my Prometheus user, but my Prometheus user is split off from root. We're not running Prometheus as its own system. It's basically a service account, and it doesn't have any permission. So you get in my system, and then you're kind of like, this is a shoehorn. Does everybody here know what a shoehorn is? This is a piece of metal that'll help you put your shoe. And it's just like, it's like this. It's like scratching with a fingernail at this. You know how long it would take me to scratch through this with my fingernail? I'd probably never get through it, right? I need some. So my point is, he doesn't have any permissions. It's the same thing when we make like immutable containers and like and what we call it's immutable, but also where they can't. Not a switch root environment. Anyways, my point is, defense in depth is this idea that you have multiple layers of control around a thing. And the way we used to have it back in the day was that we started with a perimeter. This is actually why when you go take a CISSP, there's a wide range of questions. You have to understand that the perimeter of your building even, and the landscaping and the lighting around your building are all important. The height of the walls around your building. A 6-foot wall doesn't stop anybody. An 8-foot wall stops all but like maybe 4% of people. I don't know if you guys know that, but like a 6-foot wall, average adult in general can just pop right over the top of a 6-foot wall. 8-foot wall, you need to have either some kind of climbing knowledge, like you have to know how to get up, or you have to be a relatively athletic person. Fat Americans aren't getting over that wall, right? Or people that don't know how to climb. So perimeter, very important. Then when people come up and they authenticate who they are, they're doing that inside of a thing called like a man trap. And then that man trap will only fail open and kick them out, or maybe even lock them in there and gas them. No, but there's all this perimeter stuff, right? And then maybe once you get in, right, once you get in from the physical, now that's the only way to gain access to the network. Some data centers have like they have no wireless policy typically. Or if they do have some ability to get to wireless from outside of the building, which some data centers I've worked in do not, for sure. But if they do, it'll drop you in a VLAN and just let you go out to the world. There's no other access. You can't even see the internal networks ever. But let's say you do beat that. Let's say you beat that, right? You figure out a way to break out of your VLAN. There's methods, there's techniques, there's all kinds of things. You find another access and you guess the password and you get in, whatever. Then the host, each individual machine, should be protected in some way, right? It should have STIGs compliance, so Secure Technical Implementation Guidelines, or CIS benchmarks, minimum security, maybe even host-based firewalls, right, that are blocking ports that can't be connected. Host-based security that's very, very common nowadays and very modular is called Zero Trust. Only devices that talk to other devices should be able to talk. But it's not a big outer wall Maria where once the wall gets kicked in by the Titans, everybody inside here is getting fucking eaten. Right? Does everybody remember? Everybody know what I'm talking about? I talk about Wall Maria, and people are like, "Oh, this guy's a nut." But yeah, if you guys know about the outer wall, It's a wonderful idea until you have 30 miles to get to that next wall and you're being chased by things that can run faster than your horses, right? And you're over open fields and then they just run you down and just start chomping on your faces or whatever. That was pretty creepy show, right? My wife loves anime with me, but she's like, should I watch that? And I'm like, you get creeped out real easy and you have nightmares. Me, I just sleep like a baby, but well, when I fall asleep, I sleep like a baby. Anyways, my point is each host is protected. Then, even if you compromise my host, let's say you get to my host and I was dumb enough to leave Ubuntu on there, and you get in, the application itself should only be decrypting and looking at the things. Let's say you can look at the application, look at the memory, some other type of stuff. You should not have access outside of what that application needs. And then, even if you were to get at the raw data, it should be sitting there in just an unusable lump. And the key next to the data should also be in an unusable lump. And only if you had separate permissions to go check out the envelope encrypted key to be able to unencrypt the data key to be able to get at the data would that data ever be useful to you. In fact, part of this right here, when we talk about data, I'll pull up a different talk that I have. And by the way, I don't know, because somebody's about to ask me, where is this presentation? I know the presentation's out there, but I don't know when I recorded this. So maybe I need to record this again, but hold on. Let me go look at presentations. This was AWS topics, and it was in my Solutions Architect Pro decks. I'm not showing you guys this because it's on another screen, but hold on. This was in my ransomware protection. This is a different talk that I did, man, years ago. I was still at AAA back here, right? And this looks like this. So hold on a second. Can you guys still see all that? Can you guys still see all that? I'm not really going over this talk, but that was when we used to study for this, and I gave you guys all the different stuff. Actually, I might need some of this for this might be useful for my dissertation, so I'm going to leave this up. But one thing I was going to show you guys was this, where the way that a ransomware attacks a company, right? If you guys are not familiar with ransomware, they come in and this is what they do. They target the organization's data, and they try to do two things. They try to capture your data so that they can threaten to release it. And then they further encrypt your data so that they can give you no access to it, no availability, right? Because confidentiality, integrity, and availability. But there's two components to it. One, they threaten to release your data that they've captured. And two, they make your data unusable, and then they threaten to charge you to get the keys, and then you got to pay them money, right? All this stuff. Well, I just want to go real quick here. How does it work? This is how the ransomware works, right? I built this stupid little thing a while back. It destroys everything. But these are the things that don't work against ransomware. But I just want to show you this one thing. Where do I have it? Apparently I just talked about it because it's not here. What I wanted to show you, this talk's recorded somewhere. But what I want to show you is if you have your data encrypted at rest, they can't do the first one. The first one, which is scary, is they'll ransom you to not release your data and things that they know about you and release it out to the world. And another way to think of that is that's a free online backup. I'm just kidding. That's terrible. But they can't get at your data, so all they did was further encrypt it, which is its own problem. But at least the first one's not there. So there's two attack vectors, let's say, of ransomware, and the first one is they try to gain access to your information, to share it and sell it, and the other one is to lock your data down, which they might still lock your data down, but at least they can't release it if you're doing this. If you are doing encrypted data at rest, you protect yourself from half of what ransomware is bad about. The other half, you need to protect your systems, but that's defense in depth, right? My point is, if the data is already encrypted, one of the two things is protected. That's what I mean to say there. Okay. So defense in depth traditional was an outer perimeter that we controlled, right? We controlled the building, the data center. In modern cloud, we don't control the perimeter anymore. In fact, I don't even know where that is. By the way, I missed something. Hold on. Most DCs I've been to don't have Wi-Fi in 300 meters of the premises. That may be true. That's probably true. Sponge Fighter. I've only been, in the last few years, I've only been in about 3 data centers in the last few years. So there's that. And then, okay. So we no longer have physical control. Again, I don't even know where data centers are for AWS. I know they're in regions, and then I know generally where they are, but I don't really know exactly where they are. And they try to keep it that way. They don't really do a lot of publishing. Could you find it out with like job postings and kind of map out where things are? Sure. But generally speaking, they don't have that like widely published. And that's probably smart. So how do we control our access? Earlier I said everything I do is an API call in how I interact with the cloud. So if you can get my API information, you can behave as me, you can interact as me, and that's a bad thing. So all of our user interactions with the cloud, all of our junior engineers, all of our users, all of our developers, they use identity and access via keys typically. Access key and a secret key, and those two keys, if they're ever compromised, will be, I don't want to say will be your undoing, but somebody could do things as them. That is how the system authenticates you and knows that you are who you are supposed to be. So identity and access, controlling that edge stuff, very important for cloud. We no longer control the perimeter. So once people get in, we can limit what the identity of the user is allowed to do. So there's some perimeter there. Typically we tag things and then have, there's a further level. We used to do role-based access control, but now we tend to do like attribute-based access control. So everybody here listening to me can be tagged as an engineer. And our role is engineer. We go to the cloud and we're all engineers and we're all happy. But then there's attributes tagged to me to be maybe like a prod and a dev and a test engineer. So I'm tagged with attributes to all of these environments. And some of you are only tagged as like our test engineers. Now you're all engineers. You're all allowed to do engineer things. But some of you are only allowed to do it where the tag aligns, the attribute tag aligns with an attribute tag on you. So now I can limit you guys to be, you're still engineers, but only in the attributable space. So like, what would it be? Like, what was I saying? Test, dev, prod. And only I and some of the other guys can maybe do prod stuff. And maybe nobody ever has prod. No human. Maybe we have a policy in our organization that no user can ever have prod tagged to them. Only the pipelines that we have. So we have some set up pipelines, and those pipelines do whatever tasks we want. There's AWS pipelines, there's Jenkins pipelines, there's whatever. Typically, they're going to be interacting via keys as well. And only those things can now, because now you have to go compromise that system and understand how it works to really do any major damage, right? In the prod environment. So anyway, so there's all this stuff. Same kind of idea. We protect data at rest. Minimum encryption for cloud data is always AES 256. I'm sure that's going to jump one day, but last I checked a few days ago, it's still 256. And then our protection of data in transit is HTTPS at layer 7 and then TLS at layer 4. TLS is at least 1.2, but typically recommended 1.3, never SSL. And TLS, do I have how TLS works? I don't have TLS working in this one, but in one of my other presentations, I teach you guys how TLS works, right? It's actually in that data security one that I was just talking about. If the wife's not home too long, then we'll keep going. We're gonna go as far as we go, guys. That's what we're gonna do. All right. Sorry, got people texting me, inviting people to a party next week. So we did Thanksgiving here yesterday, and probably had, what do we have? We had 25 people here, so not that much. But this party next weekend will probably have about 55 to 65 people here. So it'll be, and then I get a game truck. I don't know if you guys have ever seen. Do you guys know what a game truck is? Or game trailer, I think it's called. See if this will come up with a little game trailer place. Epic Game Trailer. Here they are. I don't know how good their website is. Let's go look at their website. Do they even have anything on here? I've been getting this game trailer for like 10 years for the kids. And it's just, it looks like this. This is the one we'll have this next time, so the kids will be playing like this. But normally we do it like this with their big trailer. But the kids have a lot of fun in there. And you might ask, because I was even telling the wife, I'm like, this is not a cheap option. But I could have, downstairs, I could put a big TV up on the wall and then do like a Switch and have like Mario Kart Racing and all this other stuff. But just hear me out for a second. If any of you have ever thrown a party, just hear me out for a second. Party starts at 5, right? And it's kids-friendly party, so like it's not all the drinking. You could drink, I guess, but hold on. Just hear me out for 1 second. The Scott's theory of running a party. everybody's gonna eat and be loud. That's life, right? Everybody's allowed. I get subs from a place called Good Sense, and then I typically get like Barrow's Pizza or some other pizza in the local area, and then we just have people have all kinds of stuff, and I have drinks and stuff. Then after that 1 hour of loudness, we could have all the kids go in the other room and play on the Switch, but it would still be loud in the house. So instead, that's when the truck comes rolling up. The truck is rolling, right? And it comes out front, gets like all the kids outside, and then a lot of the adults go hang out outside too. And then I have these drift trikes. Have you guys ever seen? Some of you probably don't know what my drift trikes are. Hold on. If you guys haven't seen the drift trikes, this is what the drift trikes look like.
I'm gonna officially say as a dad, I think this is a bad idea. But I'm still gonna record it as a dad. Go, Kale, go.
My son wanted to go. This was a few years back. He wanted to go when it rains. We go ride him. But this was too much rain, and he wanted to go out in it. And I said, "All right, I think as a dad, it's a bad idea, but go."
I'm gonna officially say as a dad, I think this is a bad idea. But I'm still gonna record it as a dad. Go, Kale, go.
So these are the drift
Doesn't
trikes if
matter,
you've never
you're
seen
about
one.
to get super wet. And here's the storm. Woo! Kale wants to go out, and oh my God, I can't even stand right there.
It was so much rain coming down. He was soaked. He was soaked by the time he got back in.
It's,
All right.
It's pretty bad, guys.
If you guys have never seen the drift trikes, and then this is what they look like. That's my brother Tom. That's Pessa. But we have a cul-de-sac right up there. We just go see, it even says dead end right there. So we were all like riding around. We always, I mean, we've been riding those things out here for years, but that's one of the best little. The wife thought I was crazy when I first got those for the party, but people love to just go out and ride on them. So then the house, like everybody that's hanging out inside is just chilling and it's quiet, and you're basically paying to get the kids out of the house. That's really what that is. It's having a party where the kids have fun, but they're not in the house being loud where all the adults just want to hang out. Because some of these friends I only see once or twice a year, you know. So we want to kind of hang out and do whatever. But all right, defense in depth. Main thing to know in the cloud is we don't control physical security anymore. So identity becomes our perimeter. That's one of the most important things I can pass on. This shared responsibility model, this comes directly from AWS, but this is true of most all the cloud providers. AWS is going to be in charge of their regions, their availability zones, their edge locations. They're going to keep that stuff up. They're going to keep it patched. They're going to keep the lights and the electricity and all that kind of stuff going. They're going to do all their hardware and global infrastructure, so their networking in between those places, that's going to be on them. They're going to do the big four: compute, storage, database, and networking. They're going to maintain those. They're going to have updated versions of compute as far as an underlying platform. They're going to have storage that's acceptable and has proper, amount of size and all that kind of stuff, and I/O for whatever they're, if they give you a certain amount of, like, you can have, it used to be 1,100 requests into like an S3 bucket every minute or something like that. I think it was something like that. And no, it was 11,000. I forget what it is. But the point is they had some limit, and they would maintain that and be able to adhere to that for whatever number of requests you had. Databases will be updated and have whatever kind of speed. Networking will be using proper protocols and all that kind of stuff. And then whatever software they have will be updated. Now you can go and you can deploy the compute and stuff like that, right? You can have platforms, applications, identity, and access management. Again, you build your users up here. This is on you. If you build out user keys and then you put them in a GitHub account, which this is probably the most common way that things get compromised, and then you push that version of Git up into the cloud or up into GitHub, and then somebody comes along and scrapes that data. Now those keys should know, if a key is ever compromised, you can never use it again. There's no uncompromising a key in this world. There's no uncompromising a password either. If you ever have a password ever compromised, toss it out. You can never use it again. And you say, what if it was on this one thing? Then never. It'll be in a list that's being tried someday, right? Something that's just a little bit faster than randomly touching everything. It'll be tried. And also, I actually kind of like this service. Azure does this. I don't know if AWS does this yet, but I remember years ago, if you ever put a password into there, it would check it against a database, and it would say, hey, you know what? This is in a database out there on the dark web. You can't use that password. And then you're like, oh, damn, can't use that password. Because you shouldn't. You shouldn't really. There's server-side encryption, file system or data. But if you're not going to use that, if you turn that stuff off, almost all of these things up here are completely configurable. You can turn them off. You can turn off TLS requirements into S3 buckets. You can allow S3 buckets to just be, data can be pushed up in a way that could be captured. So you can, I mean, this is one of these things. This is, I'm going to use a reference that I think only like 1 or 2 people will get, but this is the Luigi Vampa right here. Anybody know who Luigi Vampa is? Anybody know who he is? You can look him up probably and know where he's from. But Luigi Vampa is like, I gave him a chance to live even if he did not take it, right? Like I gave you a chance to live, but you did not take it because that other guy killed you in a knife fight. That's Luigi Vampa. Count of Monte Cristo, right? It's as Edmond Dantes escapes the Chateau d'If, and then he ends up. There you go. I got it right. All right. So the customer responsibility kind of goes like this. The data I put in the configurations that I control are on me. If I turn stuff off for simplicity, if I give like contractors identity access management, but I don't make it automatically, it can very easily automatically expire after 8 weeks. And then the only problem that would ever happen there is I just have to go give them more time. That is much better and much smarter than just giving people access forever in your accounts. And that causes people problems all the time. Then in the cloud is us, and of the cloud is what they're going to keep track of, right? So cloud service providers, there's a bunch of them. This is kind of old, but it's still a good way to kind of look between them. And there's a bunch of blogs and stuff that'll tell you about the different pieces. And it's funny, they have very similar names, but they obviously, for probably, trademark reasons, have different names for things. AWS has the Elastic, ECS is Elastic Container Service, and then EKS is Elastic Kubernetes Service, right? And then Microsoft Azure just has AKS, which is Azure Kubernetes Service. And then Google Cloud Platform is just the Kubernetes engine, right? Like, just a bunch of different ways to look at all this kind of stuff. Juan, you said that a while ago. I apologize. I haven't even looked at that. But you're getting your CISSP studying. Oh, you already did your CISSP though. So yeah. I studied. I gave that test its respect, but just because I didn't want to pay for it again. You don't get a second shot, guys, on a CISSP, which used to be about $795. I think it's a little higher now. Used to be like $795. You didn't get a second shot. You had to pass it. So. Otherwise, you go spend your $795 again. By the way, I paid for that one myself. My company didn't pay for that. And I did that. I got my CISSP, some of you guys know this, only so that when I argued with my security team, my emails back to them had CISSP after my name. No other place did I ever put that. But when I talked to my security team, I did. That was funny to me. There's common issues in the cloud, but this is actually funny. I tell people when you talk about these 4 common issues, connectivity, problems with connecting, latency, systems are not functioning as fast as you thought they were, capacity and security. The common issues are almost always fixed by well architecting up front. So if you go and you look at like the well architected framework for your different whatever service you want, and you follow the standards and you follow the best practices, these things that are like common, and the reason these are common issues is because a lot of people run into them, right? They're common. But they're commonly, they're well known, so you could just avoid them by following the best practice. In fact, in a lot of cases, you almost have to purposely avoid the best practice, which I think is wild, right? But those are common issues. So, yeah, connectivity, latency, capacity. And you might say, well, where would I go, right? Where would I go to look at this? Well, there's the well-architected framework. Right, well-architected framework is big for AWS. There's other ones for other cloud providers, obviously, but AWS, I'm pretty familiar with their well-architected. And one of the things, I used to always show this when we were studying for our Solutions Architect Associate and Pro, and when I was studying this with everybody, you would come in here and it used to all be open. I imagine it's still open somewhere, but like they're trying to charge people for all this stuff now. Stuff used to all be free. Maybe there's probably a place somewhere in here where I can just find it all still, but they would have all the different architecture stuff out there, different topics and things people were talking about. One of my favorite ones to show people is serverless land. So serverless land is their event-driven architecture. So Event driven is one of these things you'll hear about a lot in the cloud. And if you go take like your developer associate, which I held at one time, my developer associate in the cloud as well, you'll learn a lot about how EventBridge works and compare that with like managed services for Kafka and some of these other ways that we could have just basically like the way I think of EventBridge or any event-driven architecture is I have like a subway station through my town, and anybody can throw data onto the subway, and then anybody can pull that data off. Well, we can lock it down, right? We can use certificates for that and only communicate with certain topics and stuff. There can be security involved. But the point is, when we first build it, we just send data up, and then somebody over here captures that and uses it like a trigger. So you've got producers and consumers, and the producers are always just writing stuff in as events occur, and then consumers are just doing things or running run books or building servers or in our lab that I actually have to finish up for tomorrow to kick off a new Docker pipeline and put our application into the Docker again from our code. We're going to use Kafka for that, right? So managed services for Kafka. But my point in showing you this is like, you can go learn about this stuff, and this is all free. All this stuff is for sure still free. And you can go look at patterns. And let's say you're like, all right, I want to use Terraform because I heard Terraform's the thing. And I want to learn about maybe application load balancer because I know that application load balancers are the way that I need to do something. And maybe I need an application load balancer to work with AWS Lambda because I just need a proof of concept. And here's the pattern. Here's some code that they've already written. And here's what that code looks like in Terraform. Terraform never ships. Some of you guys know this. I'm probably going to go real basic. But if you want to get a Terraform certification, they're only $75, but you do got to study. I have study materials up in our Discord too. But Terraform doesn't ship with providers. You got to download a provider. So in this case, we're going to download the HashiCorp AWS provider. That will then be in whatever directory down in I think it's .providers or .terraform or something like that. And then you'll find the providers. The reason they do that is because then you can ship Terraform really lightweight without having hundreds of thousands of providers of all these things. You only download what you need. You can say like this version, right? Something like, so that'll be locked into 4.52, but any of the patch versions, so right, major, minor, patch, any of the patch versions would be there. And then down here would be, whatever we're going to set up out in the cloud for those things. Now, when you do HashiCorp Terraform, when you run Terraform, the first thing you have to do is do a Terraform init, and it'll download all your providers, and then you can do your Terraform apply or your Terraform destroy or whatever you're doing in an environment. The power of Terraform, really, at the end of the day, is Terraform has a state file called .tf state, and that Terraform state file keeps track of all the resources that Terraform's keeping track of for your system. That's, by the way, stored in JSON. You can edit it, but I highly advise you don't ever edit it. And then you can either create or destroy these things very simply with this. At the end of the day, guys, this is what we call, this kind of code like this is a declarative syntax, right? Declarative syntax of HashiCorp language, HCL. And all it is doing is going and building the API calls for you that you could do manually on your own if you wanted to. And then Terraform's, one of its great powers is that it stores it in a .tf state file. Then it knows what it's tracking, and then it can tear things down, build, there's all that stuff. All right. All that stuff to say, connectivity, latency, capacity, and security should not be problems for you if you're doing stuff correctly in the cloud. All right. And then review, we talked about what is cloud computing. It is a well-defined standard inside of the cloud. It's a NIST 800-145 for the standard. Cloud deployment models are public, private, hybrid, and cloud, and you'll run into all different variations of them. Often you won't hear somebody be like, oh, this is a private cloud and we only do these things in a private cloud. It's just, this is more of like a categorization for you in your head, right? Cloud service models, how are we giving those services out to people? Typically infrastructure or software or platform. Infrastructure, platform, software. And the more you go towards software, the more responsibility of the cloud provider. Typically a little more cost for you, but still often less cost than building out hardware, applying something, maintaining it, having guys like me running around data center. I have a buddy who he left AAA a while ago. Actually, he was pretty active in our server for a while, and then he disappeared. And I found out the reason he wasn't active anymore was he had fallen. He lives in Finland, and he had fallen on a trail and broken his arm. and they had to come in and they had to cart him out. It took him 4 hours to get him off this trail because he couldn't walk. He fell and he broke his arm and he was jacked up. They had to put him. Man, this was terrible. He called it like a tarp, but he said there was a name for it. And then they like drug him out via ATV to get him off this trail. He said it's the worst pain of his life. And then he sent me and my brother. I have pictures of this. I'm not going to show it to anybody, but I got pictures of his arm broken with like 12 or like 18 pins into his bone to like set his arm from how bad he fell and broke it. Anyways, all that stuff. The reason I brought him up wasn't to tell you guys about that. Brought it up because he's an architect and he works for this company that they do all deployments in the cloud via Elastic Beanstalk, all AWS, all Elastic Beanstalk, right? If you guys know anything about Elastic Beanstalk, you don't need a guy like me. And when I talked to him last, I said, hey, do you need guys like me yet at your company? He goes, no, we don't need you. I'm a server guy, right? I keep servers running. I go touch servers every day. I fiddle about with the knobs on the side of servers. And that's what I do, right? Like, and most of the time they're virtual servers nowadays, but they're Linux boxes, right? I build Linux boxes. But companies don't need a Linux guy. Not if you're going to be properly deploying things with Elastic Beanstalk and you're an application company. His company deploys applications, software as a service type stuff. He doesn't need a guy like me. I'm a very expensive resource for his type of company. You know, you have 5 or 6 of me on a company. You're paying over $1 million in salary for a few of us. I'm not even talking about the taxes you then pay, and also probably you're paying a pretty good other compensation type stuff on top of our base salaries, right? It starts to get expensive, right? So he can just deploy these things up. My point in saying all that is not every company needs all of these resources, and that's one of the powerful things about the cloud. It used to be if you wanted to build a company up, you had to have the hardware, you had to have all this stuff, you had to do all the security, you had to adhere to all these things, and that's just not practical for a lot of companies. It takes you 3 months to get to market, and in this modern day and age, people are just popping stuff up all over the place. Yeah. Cloud service providers, obviously there's a bunch of them. And then common issues in cloud environments. Build your stuff right. You won't have to worry about those kind of things. So, all right. If you have questions, let me know. Wait, does this one do it? Hold on. Nah, this one doesn't do it. I have some where it has a little thing that comes down as the questions are being asked. But I didn't put it on this one. So, all right. What am I thinking here? That's probably bright. We'll go to something darker. Let me pull up. I did say we could learn Linux through the Socratic method if you guys wanted to go through some of these. This is kind of a fun little talk that I do where we just like kind of bounce stuff off. So if you guys are familiar with the Socratic method, it's actually funny. I was reading a thing the other day with a college. I don't know if it was a block of research or what, but this college had provided, they had deployed this basically like a Socratic tutor for students. And the Socratic method is a method you could use for yourself. You can have a college professor like me talk you through it or whatever. But what it is we just ask questions like, how do you know a thing? And what do you know about this? And you basically just either to yourself or out loud or in a system, prove things to yourself. I think the Socratic method is tremendously useful for troubleshooting. Because you're sitting there asking yourself, what do I know about this system? And how do I know it? And what's my assumption? Can I test my assumption? And it's just this method of almost like you're playing catch. Anybody here ever watch It's Always Sunny in Philadelphia? Mac is always asking his dad, can we have a catch, Dad? And his dad's always like blowing him off. Well, in the episodes where his dad is there, his dad's a criminal convict, right? He's like, can we have a catch, Dad? And he never has a catch with his dad. It's kind of funny. But anyways, we can ask ourselves questions and then we can understand how we know things. So I'll pull this up and move this so it's just out of the way like that. And a lot of times when I do this one, I'm not going to do it today, but I will. Let's go to Rocky 2 so I'm out of the way. We'll hop on one of my boxes that we just use for messing around and stuff. And we'll talk through some stuff. If anybody wants to do this with me, you can. I need to re-record this one of these days. This is a long presentation. We're not going to get through all of it tonight. But this learning Linux through the Socratic method, it's about 6 hours worth of stuff that we have to talk through and work on and stuff. But they're very simple questions. And they're like, can you do this? Do you know this? Why would you assume that? And then we'll just kind of talk through things and work on it. So if anybody wants to work on some of that stuff, if you don't have a shell to get in, if you say, Scott, I'd love to follow along, but I don't have a place to do that. you can go here. Let's get rid of the Epic Game Trailer. And let's just go to Killer Coda. Killer Coda is a free website out there. And you can go to any of the Sandbox channels, but I'll give you guys one of mine if you want. And we'll go to Linux Labs, 36 of them. And I'll just start you out with one of these, like look around the Linux system. And you can do the lab if you wanted, but also you could just use this Linux lab. I'll link this to you guys here. You could just do the Linux lab in any Linux terminal that you had. All right. So, learning Linux through the Socratic method. The first one is CPU topics. And this actually auto moves forward every 3 minutes, I think. This thing moves to the next slide. Hold on, guys. I got to check something real quick here. Got a lot of messages from people. Oh, I got a message. All right. One more second, guys. Probably should take a break because I've been talking this whole time, but we'll get into it here. All right. Let's get into it. Outcast and Wanderer, how's it going? So CPU topics. The first one is, could you, if you went to a Linux server that you've never been on before, and maybe you get a call out, or maybe, shoot, you're just looking around a system, you're new to a company, they don't have good documentation. Do you know how many CPUs this system has right here? So I'm on a Rocky box. I can see a bunch of information about it. Can I list out the number of CPUs that are on this server? Do I know how to do that? There's a lot of, I would almost say, like indirect ways to find that out too. But do you know how to do it, right? Because like at the end of the day, guys, right? Like if you're an admin somewhere and you're gonna do that, and you're asking yourself questions. You're like, well, I need to know how many CPUs are on the server to see if this works, or to see if it meets this minimum standard by a company, or whatever the reasoning is. Can you prove to yourself? Do you know how many CPUs are on a server? And it's not, you're not proving this to me like to win some championship here or something. What you're doing is you're proving it to yourself, because I'm not going to be there on that call in the middle of the night when you get called out, unless you also call me out. But I mean, like, you're going to be working for your company doing stuff. So this is this. You could use BTOP if BTOP's there. I don't think I have BTOP on these. HTOP? Nope, don't have that. Top, maybe. Does Top tell me how many CPUs there are? I see that there are CPUs. Right? I see the usage of the CPUs. But does that tell me how many CPUs are there? I don't see it right there. So what are some ways that we might do? I'll tell you guys here. This isn't like super critical. I'm not like trying to hammer anybody. I'm not trying to make anybody feel like they're not as smart or any of that kind of stuff. That's not the point of this. The point of this is just like, well, do I when the fire's on know how to do this stuff, right? Is this the same stream that's on you? Yeah, Evo, it is. Yeah. We're in both locations. I'm here and there. But the thing is, most of the time, because Twitch doesn't store things very long, if you're over on the YouTube side, you see stuff. So there's LSCPU. Somebody just said LSCPU. That's a good one. That gives a lot of information. But at the end of the day, I do see that I've got CPUs online 0 and 1. So there's 2 of them. I also see the word 2 right there, or the number 2. So yeah, I see that LSCPU would do it. Yeah. How about a short one? So I'll show you guys how I used to do it back in the day. I used to do cat proc cmd cat proc CPU info, and then I would grep-i for proc, right? That's how I used to do it. But there's a cheaper way. There's even shorter way to do it, which is a way. And by the way, once you know how to do whatever you're doing, and by the way, I didn't want to count them, so I would do this. That's how I used to do it. But I need a number, maybe for a script that I'm going to run. And the script won't run on a server unless it has at least 4 CPUs. I've seen that, actually. I've seen that quite a bit. But one that's very common nowadays is nproc. Nproc will just tell you the number of processors. But LSCPU will do it. Cat proc CPU info will do it. Actually, you know what? While we're doing this, if we want, I have the answers to this. In fact, I'll pull them up, because again, this is all open kimono stuff, guys. I'm not trying to be the only one with the answers. Let's go grab this real quick. And then let's go pull up, this is my questions when we have guests, right? go pull up. I have Socratic answers. Where are they at? Socratic answers. I should have Socratic answers. Give me a second. Might have blown by it when I was going too fast. There's Socratic. That's services. Admin services. Here's Socratic Linux answers. So these are a bunch of Linux answers from when we've done this in the past. People give me all kinds of good ones, and I love them, right? So I just keep adding to them. But I'll move this down a little bit like this. So the first one here was, can you list the number of CPUs? Look at all these different answers people have had. These are all good. There was a great Python one time. Look, Python 3-C, import multiprocessing as MP, and then just print MP CPU count. And you can try that. You can say, well, does that work? If I have Python 3 in here and I have multiprocessing, and I use it, you can import it with a shorter name if you want as MP. Then you can print mp.cpu count as a function. And it'll give you, yeah, there's my CPU count. You may even be able to use that for some other things, but I don't know all of the values and functions that are in there. But we could probably list them all out if we wanted to, right? I'd have to go figure out how to do that because I don't use that much Python. But I know that once you've imported something and you have it, you can go look at all the functions, right? I'm sure somebody here even knows how to do that. Somebody here probably uses Python all day, but I don't. This is one that I used to use catproc CPU info grep-i proc, and then I would pipe it to word count-L because I don't want to count the numbers. I'm too lazy. So can you tell me the speed in megahertz of this system? Well, there's a few ways. dmessage will show you how the server booted, and that may give you, here's our speed of the system, 2.4 gigahertz, right? Or 2400 megahertz, right? Han Sohai, can you ask a question? You just did, but also you can, yes. You can ask as many questions as you want around here. Let me move that up a little bit so it's not behind my head. I'm getting all claustrophobic here. No, I'm just kidding. Not that bad. Move it up. Move it up so it's in line because that bugs me if it's not symmetrical. All right, so can you tell me the speed in megahertz of this system? Yeah, here's some commands. LSCPU would give you that same type of information. And there's the 2.4 gigahertz right there. I should also be able to see it. I see it in some other spots as well, but there for sure we see 2.4 gigahertz. Boom. Do we see it up here a little bit too? Nope. Still useful. We could also see the size of our caches. Maybe that's important for something. Yeah. Han Sohai, you can ask any question you want, sure. As long as I got time to answer it here, I'll answer whatever you can, whatever you ask me. What is the manufacturer of the chip? And can, by the way, might there be a reason why you'd want to know the manufacturer of a chip, even if it's a virtual machine like this? You guys think there's a reason you might? I can think of a few, but maybe you know. He said, I know Bash don't have concepts like classes, polymorphism, encapsulation, etc., and Python has those. But can Python do everything that Bash could do? Han Sohai, there are... Let me think of how to answer that. I think you probably could do everything with Python that you wanted to do with Bash in a non like interactive way. Yes, I think because I know Python has it's got all kinds of capabilities. But could you run it as a shell? You'd probably have a little bit more of a hard time with that. But could you like interact and do things on an operating system the same as Bash in a non-interactive way? I think so. Yeah, I really do think you could. I wouldn't normally use it like that, I guess, but I mean, yeah. And actually, to that point, Han Sohai, there are C shells and corn shells that are older programming languages. C is still around, obviously, but people run those instead of Bash. So you can run other shells besides Bash as well. So, yeah, Hatebringer, you said you want to know if you can use extension instructions. I'm sure that's one. Two, I know sometimes I run software that's been tested on very specific, like especially like high performance compute and like scientific stuff that's been tested only for certain underlying architectures of chips and specific flags on chips and those kind of things. So sometimes you have to validate, and you might say, Scott, so I got to go look at that for some. No. Typically, it'll be tested to a certain type of like Intel or we know all Intel Xeon type processors could handle it, or all of the Sandy Bridge or whatever can handle it. And then really all you're checking is that across 1,000 machines, they're all Sandy Bridge. They're not like 20 machines that got redropped back in that have some newer one that probably would work fine anyways. But the point is, like, maybe you want to check across, like, a lot of the stuff I show you guys, we're doing like simple on one machine, but at scale, we just want to do it against a bunch of machines and make sure it's exactly the same. That's very common. Like, we do this like walk around stuff, and some of you probably think, oh, that's so simple, like this and this. It is very simple, but you got to be able to do simple. There's this old saying, if you can't do it slow, you can't do it fast. And it's the same idea here. If you can't do it on one machine, how do you expect to do it on 1,000, right? I can show you all the looping constructs and all the Ansible to go hit 1,000 machines, but if I can't get you to do these basic things, so again, this is more of a test for yourselves. Just like think like, hey, do I know how to tell the architecture of a chip? I never even thought about telling the architecture of a chip before. Yeah, uname-m. How does the kernel think that it's interacting with this chip? LSCPU, and down right here, we have that we are on a x86-64 chip. It's not the only player in the game. ARM64 is very, very big. In fact, in the top 10, in the top 500 fastest high-performance compute in the world, in the top 10 currently, there's still the Fukujitsu or whatever its name is, a Fukuju or whatever. Yeah, it's something like that. It's still in the top 10 fastest, and it was released back in 2020 on all ARM64, right? So it's got a smaller what is that, like heat profile and a smaller electricity profile than other supercomputers in the same genre. So and then Han Sohai, you asked, so to answer your question, because now you're back from ads, Python can probably do all the same things in a non-interactive way, but interactively you're going to want to use like bash or C shell or K shell or some type of shell thing. But could Python probably do all of those same things that bash could do? Yeah, probably. I just don't know how they'd make it all work with a command line. But yeah, people don't necessarily use it that way. But could they? I'm sure I've seen people program with like guitars. Like they write programming languages that are written to take, like, just for fun, just because they could. And I mean, at the end of the day, you could do something, but I mean, you probably would have, it would be more of like a fun project or a pet project than something you would do professionally. Because typically, like for me, in any of my environments, I'm using bash everywhere. And then the teams that I work on, we have agreed we're going to use Ansible for this type of stuff. We're going to use, some kind of bash for this kind of stuff. And different scripts and different things that we run have different, I wouldn't call them requirements, but kind of like just like soft team agreements. Like, hey, this is how we're going to build stuff. Because then I'm not the only guy that can maintain something. If it's like me and 3 guys on my team that can do Ansible, but then there's 7 other dudes that are just going to be able to be like, I'm never going to have to do any of that stuff. That's not either fair or fun, right? Can we see if this system is physical or virtual? If LShow is there, if it's not, let's do this. DNF what provides that command if we can find it. So it's the command. Now this is a stateless node in my environment, so if I wipe him and he comes back up, he'll lose all this data, but here he is. Here's what repository it's coming from, and we have classes that show you guys on that. Like, if any of you guys are interested, we have stuff down in the Discord, free courses, and one of the courses that goes through security architecture deals with repositories and building your own repositories and all that crap. But right here, DNF install LShow, we've got it now, and I should be able to just press up a few times and run that command. And if there's system information here, we should be able to say, is this a physical box? Well, the vendor is Zen, which is typically a type 1 type hypervisor. And yeah, we know that it's hardware, virtual machine, DOMU. I don't know what DOMU is, right? But it's definitely virtualized. So we know that there. DMI decode -S. So DMI decode, one of the best things you can figure out in Linux. And system manufacturer. That'll tell you it's Zen. You can also just do a DMI decode and dump and say grep-i for virt maybe, and see if there's any virtualization. Or I used to use prod and look for product name. So in that it's HVM. or maybe in this case, maybe like system. It would tell me information. So, or I can just dump everything to the screen and look at it, right? And see, there I see Zen, right? Different information that's available. Sometimes we have the command vert what, but you can't always depend on all the tools to always be there. So sometimes you got to learn some of these other ways to do it. Some environments are going to be different. And you might say, well, no, I'll never in a company build an environment that's different, so I can always just use the same commands. And you go, yeah, well, that's wonderful going forward. But when you come into a company, you will have inherited all the problems before you. All the problems that drove the other admin out or other engineers out, you got hired to fix. And nobody ever tells you that it's true. You inherit all technical debt. You know, you're like, I am not the sins of my father. Well, you are the sins of the engineer before you because, well, you have to deal with them. You know, if there's a server that just randomly shuts off every 3 days and you're the engineer that now owns that server, sucks, right? But I mean, we want to get paid, so we got to work for company. I mean, I guess if you can find a way to like run a company and not have to answer to anybody, maybe you can get around that, but no, we have to know how to find this stuff so that we can go figure it out. And in this case, I can tell that this is a virtual machine. So when I'm going to try to find the machine, I'm probably going to be jumping into my virtualized hypervisors and looking at that kind of stuff. I'm not going to go out looking on the floor or looking through my IPMI tables or IPAM, stuff for which server this is physically. It's probably not a physical server. It's virtual, right? I'm not going to go plug a console into it. I'm going to get a console like this, right? Right? This is my console program for my home lab here. I also have Proxmox. I can show you that over here. Where's it at? Went away. Proxmox. Am I still logged in? Yeah, so here's my Proxmox server environment, right? And then that's kind of like a console. And then I have consoles into all my other servers here as well, right? In fact, I can be on the console with this Rocky server if I want right here. So here's my Rocky 2 that I'm in. And I could be at the console, like let's say networking wasn't working anymore, I could go get direct console access, but I could only do that if I knew if it was physical or virtual. I have to know how to get my other path to get where those things are, or it won't work. All right. So can you tell me if this isn't physical or virtual? Yeah, we know. All right. Can you spin up the CPU to high load for 3 minutes? So could I spin this up? Well, if the stress command is there, stress is not there, so I can DNF what provides stress. It's just stress, but what provides stress. And if it finds it in one of the repos, there it is, and I can install it. DNF-y install stress. Typically, you won't do, well, a DNF-y, but also you typically won't be installing in random systems. But down in your dev or test environments, sometimes you'll have servers where you can install stuff just to test right before you go pushing it everywhere. So now I have stress. And I might say stress, and I'll say pretend like there's 4 CPUs, but we know there's only 2. And we'll do a timeout of 180 seconds. So for 3 minutes, we'll stress up the system Rocky here a little bit. Before we do that real quick, do we have monitoring of this server? Could we, this is a little outside of this, but let's say that we had lab. Where's my lab? I've got to log in Microphonic because I haven't been in there for a while. Hold on. All right. So we're looking at this Rocky 2 server. In fact, we can go, guys, we can go just to the Rocky 2 instance. What is he? Real quick. Because, by the way, we could do it by name down here. But he's 52, right? So we're gonna limit this only to give us information about him as we speed him up. We're gonna spin him up and we're gonna go pretty hard on just this one box. So here is just this one server. And we're going to look at him for just the last 5 minutes here. So here's my CPU, memory, all this stuff on just this one server, right? I'm looking at just, hold on. Oh, whoops. Get rid of that other one. Get out of here. So just the one. Oh, here he is. Okay. All right. So here's his last. We're going to spin him up. We're going to make him go hard. As he spins up and goes a little hard, we'll see over here that his CPU is going to spin up. This refreshes every 15 seconds, but we can make it every... we'll leave it at 15 seconds. That's fine. We're going to start to see some of this spin up. Where is open file? We'll just watch CPU right here. And that's 15% right there, because now watch. Now the scale went way up to 100%. So the scale was down here, and it was showing the whole thing, but it was at 15%. Now it jumped to 100% right there. We're at 100% usage. So system load is about to jump up. These are going to move up in 3 ways. You're going to see, this is the 1 minute. So 1 minute is a very small window that slides, so it's going to spike. 5 minutes is a longer window. A 3 minute thing, a 3 minute sliding 100% for 5 minutes isn't going to move that up that much. And then the 15-minute window, which is really wide, is going to have a very small, like the 3 minutes is only 1/5 of that, right? So this is only going to move up to about 1/5 of that, which is what, 20%. So we'll only see this go up to about 20% as far as that goes, right? But the system load, we can actually see that spin up on the system. And then we'll see it drop back down when we're done. So we can just hang out here and watch that for a little bit if we wanted to. Hatebringer said, you know Proxmox, but what's XCPNG is a dinosaur of a forgotten bygone era. How's that? No, XCPNG is the fork of Zen when Zen was bought by Oracle. So it's a fine tool. I use it in the home lab. I have a lot of stuff on it. Let me pull it up real quick. I have a lot of stuff on it. I've got 4 physical boxes on it. But my new stuff going forward will be going on Proxmox. So my big Proxmox server is this big old chunky server that's got all kinds of... He's got 512 gigs of RAM. He's got 80 CPUs in him. He's pretty big server. These boxes here all together are barely... They're not even up to his RAM on just this one box. So I've been migrating stuff over there. And then I was testing our Werewolf stuff the other day, so Werewolf goes over there too. But hopefully to answer the question, the thing is, it's just another way to maintain your stuff. It's a XCPNG, strictly speaking, is a Type 1 hypervisor that I can then deploy systems to. There's no maintained Terraform provider for it, so it's not great. There's not a maintained Ansible operator for it. The Ansible operator I use is very old. I can deploy stuff to it and like pull it off, but it's like a rickety old bridge. It's kind of shitty. If you've ever been around for it, like when I deploy stuff, it's not... It works. Don't get me wrong, it works. It's just... I would never, ever, ever in a million years productionalize that with a real company. Proxmox, pretty productionable. I mean, you turn this in production in a real company. XCPNG, I wouldn't do that. Yeah, that Hatebringer, there's like nothing going on this. This guy's just chilling right now. This Rocky 4 was to prove that Werewolf could deploy over there. So now, you guys ever seen magnetic sand? You guys know how magnetic sand will just sit there and you put a magnet like this and it goes like this? Like slowly over time it pulls over the top. I know this is a silly way to think of it, but this is, as an engineer, the way I think of, like, I add a new system and then can my deployer deploy to it? Once my deployer can deploy to it, I can slowly start to like assimilate over the top of it. Well, that's what this Rocky 4 instance was I deployed from my Rocky in my other environment, or I deployed Rocky 4 from Werewolf in my other environment. And once I could do that, this whole thing is owned by Werewolf if I want it to be. And that was super useful. I haven't done anything since I did that. I have all kinds of shit in my home lab to build, guys. I just haven't gotten around to doing it. Let's go back over here. Look, there was the spike for the 1 minute window. Here was the very low spike for the 5 minute window. And then look, the 15-minute window was like, It was 100% utilization during that time, but didn't bug us too much. Yeah, see, there's that 100% utilization. But now it's back to chilling. Over here, we could have seen it when it was happening. This would have turned red up here for the CPU used. But this is like a HUD. This is a heads-up display of like what's going on right now in the lab. So there's different values and different things that are interesting to us. Anyways, all right. So all right, now we're into memory topics. So we did all those ways to. There's a bunch of ways to spin up CPU. By the way, some of you are going to ask, is this somewhere in the Discord? This is in the Discord, right? It's under the Pretty sure it's under presentations. So if you're like, well, I want to go through all these on my own at my leisure. Okay. There is the Socratic method for, well, there's one for Linux right here. There's a Socratic method for Linux if you guys want it. And then here are the notes. So here's the Socratic Linux notes that I have. And then it goes on for 302 more lines. So you could just type these commands. I tell the guys, you could just type these commands in while asking yourself these questions. And if you're not super familiar, I think you would, over the course of time, figure out kind of what's going on in a Linux system. Yeah. So I think you guys can do it. If I didn't think everybody could do this, I wouldn't bother streaming, because I'd just be like, well, me and like the handful of engineers I know that do this are the only people that can do it, and F everybody else, they can't do it. But I do think everybody can do this, and that's why we have ProLUG, and that's why we have this place for people to go and practice this craft, because I think, now are there people that are going to excel in this more than others? Sure. I know people that are better at this than me, probably most of them. But the point is, like, I think anybody can do this if they wanted to. Now, I will tell you this. Not everybody wants to look at this all day. This right here, some people are like, no, F that. I'm not sitting at a command line all day. And I respect that. Because, guys, in the same vein that you say that, and you say, well, Scott, you know, I can't do that. And I say, I can't look at a database all day. Guys, I can get in a database and I can do SQL queries and stuff. I would just be like, you guys ever seen that guy that's like, there's a meme and he's like, that's what I would look like. I'd just be like this all day. I'd be like, I don't want to, like, or that guy that goes, ooh, brother, what is that? That's what I would feel like all day if I did database. Nothing wrong with database work. I think it's fine work. I know really smart engineers that do database work. Not for me. Same thing with this. I think anybody could do this, but it's not for everybody, right? Because maybe maybe this bugs you. Maybe that gives you a headache. I know people who look at this with a white background, and I'm just like, oh, I don't know how you're not snowblind. Like I have these big giant screens in front of me, and if I had like just white light coming at me all day, I have one little light, because if I turn it off, I won't be as pretty, right? So like that one light kind of like makes the black, the green background behind me look better. But other than that, like if I had light in my face all day, it would kill me. Right? Like I already have bad enough vision, right? Like I can't risk making this stuff any worse. So, all right, can you tell me how much RAM we have, or could you tell yourself? Right, you're on a system and you've never been on it. What's going on with the RAM? What's going on here? We got free-m. That shows me the information in one way. I could do free-g, but is that useful? I mean, free-m shows me one way. Cat proc mem info will show me another way, and this is reading directly from the system. I can come right here and I go, okay, memory available is some amount of kilobytes. Okay. How much total mem do I have there? And then I go start counting on my fingers. So these filters that we have here can help out a little bit. One that I kind of like, especially for like more junior, as people are first starting, maybe -HT. This is a good one. So this will show you in gigabytes. So that's what those are. And that's how many, we typically just call them gigabytes, but that is actually truly being read as gigabytes. The difference between them doesn't matter to most people, but it's a sales term versus an engineering term, right? But okay, so there's your bytes, and specifically gigabytes, we'll call it for now. We got 7.7, but we had allocated 8 gigs, and then you say, well, what's the difference? Well, it's 1,000 versus 1,024, right? But how much is free? Could I see that I have not utilized all of a resource? Yeah. I can see that I've used 2.8 of 7.7, so I have approximately 5 gigs free. If you were to ask me, I have well over 50% free, and that might be a good enough answer at some level if somebody asks me. Like, could those servers, like the new version of this Java process that we're going to run when we patch, we've proven that it uses 50% more RAM than it currently uses on the system. And I just look at this at a real quick, what we call like spitball, or what we sometimes call cocktail math. And I can look at that and go, yeah, if that 2.8 if the whole 2.8 was just your application, which it's not, but let's say it was, and that got 50% bigger, so 1.4 more, I'm just cocktail mathing it up, right? Yeah, the system can handle that, sure, right? And I could give that answer in a meeting and be confident that when I go back, I knew what I was talking about, or I could, type the command in real quick and I would know these things. So how much RAM do we have used? Yeah, we have the additional capacity for it. But maybe I go and I look in our system, and this is why it's nice to have historical data. They might say, hey, you know what, we really need this to be stable. Does it have that support? Do we have that capability all the time? And I say, you know, I'm gonna have to get back to you on that. But let me give you that here shortly. Or maybe I just pull it up like this, like I want to impress them. And I say, okay, let's do the last 30 days for still that one instance. And then I go down and I look at the memory usage, right? Where's my memory usage? Network, that's network, that's TCP. I should have memory usage. Where's it at? Disk space, internet traffic. Here's my overall memory load, right? And I can tell you right now, in the last 30 days on that system has never been above 35%, well, 36% memory. So if you were to add from 36% another 50% to that, right? For that is what, 18% more. We're not going to go over the top of that. In a 1 month usage time frame, yes, we have the capacity to handle that. Now, would I typically talk capacity as an engineer? It depends who's asking me. Like I would show this to like my manager, and then I would send this to my manager, like just grab the screenshot and show it to him and say, hey, look, it's the last 30 days. I might even circle this. It's the last 30 days. It's on that particular set of nodes that they wanted. And yes, capacity is there. And then he can go and he can look up other stuff. Typically a lot of times we'll give management like bigger ranges on graphs like this so that they can look at capacity stuff like that. And they can look for trends and that kind of stuff. But yeah, could my system handle that? Yeah, from the data that I have available to me and my tracking, yes, my system can handle that kind of. But this is the thing that we have. So can we tell me how much RAM we have used? Yes. Here's how you might do it. There's also HTOP and there's also NeoFetch. I don't really use either of those, but we've installed those to the system before to look at. There's also BTOP. Let's just install HTOP. Right, HTOP will show me how much memory we're using. And look, it kind of showed it that same. It's got our quick little visual for us or whatever. We used to use HTOP in the environment when we were running the we had a big. We were running an LLM on like a 36 core CPU. We had no GPUs in my home lab environment, and it was trying to just chew through things, and we would watch it chew through. It was kind of funny. All right, but then could you tell me how much RAM we have used? Yeah, that's an important question. How much do we have free and how much we have used? May sound like the same question, and they kind of are. You just have to make sure that you can do that in your head. Do I understand how much is used and how much is free? Yeah, I can go do some quick math and figure that out, right? All right, the next one. Can you tell me how much swap we have? So it says F10 to quit. That's funny. Free-M, free-T, again, free-HT may show us this. And how much swap are we using on this system? Well, we have 0 used and 0 free. We're not even running swap on this system. There's a very specific reason for that in this home lab box for my stateless nodes. But maybe over on the real jump box, so this is my real jump box that we use, we probably do have some swap. We have 8 gigs of swap available on this one. And why? Why do we have swap on this system, right? And why are we using that? And here's swap. Here's the allocation of swap right here inside of this logical volume carved from this volume group, right? And this volume group is made up of this one disk that's there. But why does this one have it and maybe this one not have it? Now, I can, like, this is not directly part of, like, the Socratic stuff. The Socratic stuff is just, can I do this simple thing? But it spins us off to all these other questions that we might ask, right? And in this question, it might be like, well, why is this Rocky system different? And now I can sit here and tell you about it, right? I'd be like Deckard Cain and say, stay a while and listen, right? Sit around the campfire and I'll identify all your stuff that you got down in the dungeon, but then also you have to come and listen to my stories, right? Haybringer said LLMs on CPU work great as well, but speed like 8-9 tokens not. Yeah. And I don't get as much into like the token side of things, but like for my home lab stuff, it was answering questions and stuff. I was using okay, I got it all in there. We could go look at it if we wanted, but what I would do is you guys could what the LLM was doing was you guys could ask it questions on here. I have a bunch of questions I think on the Let me see. Ask. Nah, maybe it's not there. Let me start this stream. The streamer bot? Hold on. Let me start this real quick. I'll show you guys. I'll just show real quick. Because looking at swap is simple. But also, why did we used to use swap versus why do we maybe not use swap anymore? That's an important thing. We still need swap on servers. Most Linux boxes want to swap, but we don't necessarily want to let them swap. So watch, I'm going to pull this up real quick. It's a little smaller. I used to do this. These commands are still active when this thing's on, but they won't work right now for you guys. Damn it. I can't get the edge. There we go. I wanted to make it smaller before I pulled it over here. I got a bunch of commands that are set up in here. So you guys could do like AI or Llama or LLM, and it used to put it in, and then it would pop back out, and I would have it show to you guys through, it would go to Loki, and then Loki would present in Grafana, so you guys would see the answers. But I was using a, oh God, what was that? It was, shit, I'll just go look it up. Hold on. Where did I have that? This box is on? I think I might have turned this box off. Is he on? Yeah, Llama's off, so it wouldn't work anyways. But God, what was it? It was only a 2.4 billion, so it was pretty small. Like train model, it was a pretty small model that I used to run, but yeah. Anyways, that's not that big a deal, but and then there's challenges and all kinds of stuff. There's a whole bunch of things you guys used to be able to ask. I don't care as much anymore. Plus, I don't really care about being queued on stream. I just want to show you guys basic Linux stuff. Can you free all of your cached memory? So we've got this shared and buffered and cached memory. Can we clear our cached memory? Do we know how to do that? There's a specific reason that we might want to do that. But buffered cached memory is sitting there being held open and typically not committed back down in any way. It's just being held open in memory. But a lot of times that's not necessarily needed, especially the way I used to run into this a lot was we would have Java processes running, and Java processes to me inside of Linux are like a black box. I'm not the application guy. I'm not developing. So my engineers would come to me and they'd say, hey, we can't start this application anymore because it doesn't have enough free memory. This was kind of a common one. And then I would say, okay, well, let's clear your cache because probably there's things that are open or something like that. So there's different ways to clear a cache, but it's typically, you can use 1 and 2, but they go and they do it different ways. You can go look at this later if you want. But it's procsys VM drop caches. And when I drop this real quick, and I go and I look at this again, typically it will clear the buffer cache. So if there were things that were not being used by my system here, you would see that it was dropped. Now, all of those are probably needed, or they're probably being held open, or they could have even been open before I got there. That actually happens sometimes as well. They get reopened. But what I will tell you is that is not an entirely safe command to run on Linux box, especially in production. I would not have done that if this was a production box, even if I was on the phone call with like a dev team. I might tell them, hey, look, man, if this is really stuck and we really need to get this going, we probably should take this system out of whatever rotation, behind some load balancer, give it a full reboot to come back up, because me doing this may still leave other things hanging. And you say, what other things could be hanging? Well, we're pretending that there's a Java process, but let's say there was, let's just say grep-i for prom, right? So here's this prom tail application, and maybe I go to this and I say lsof. So I'm looking at the process for all the open files that's looking at. And maybe we clear out the cache and some other things, and maybe we even reboot that service, but there's just something out here happening. So it's running iNotify. Maybe iNotify's been, replaced on my system. There's these dynamic libraries that may have been updated. You can replace and update dynamic libraries, but this process itself is still running whatever ones it originally loaded with, which is one of the reasons people like to reboot servers when they patch, is because this is still pointing to all the link libraries when this process first originally started, right? There's a lot to that you guys can go look into if you want. But my point is, a lot of times we have other tools in place that it doesn't just have to be like, hey, let's try to keep this server limping along. We tend to have load balancers in front of things, and then the individual servers themselves are I don't want to call them ephemeral because they're not, but they're much less important from like, hey, we need to keep this thing limping along right now and not let it die, and you know, that kind of stuff. So, what was the last one? It was just like spin up the memory. Yeah, generate high memory load is just another stress command. But here's all these commands. Again, these are all out on the Discord if you guys want them. And then the VM4 will use virtual machines. If you spin these Rocky nodes up, because of the fact that they are a TempFS file system from start to finish, they're a virtual machine that has no back-end disk. There's no back-end disk on this. Now, okay, there are these other back-end disks over here, but they are the storage NFS, right? They're not connected directly. But if you spin up the memory high on these boxes, you can cause the server to crash because it's kind of like you're playing with. So we've got 8 gigs here of memory, but we also have 8 gigs of disk space, and the disk space is just being run in RAM. So you could also fill this up and crash this box. So these boxes are I wouldn't call them unstable. They just reboot in a stateless way. But these are the kinds of servers that we build for like big science applications and stuff. The individual server itself, we don't give a shit about, right? They don't really care. Because we do care what happened on it. Its logs are important. But the server itself, it is truly ephemeral. Not in my home lab as much, but this is one of the server boxes for you guys to use for people that jump into our servers. So if you guys are ever wondering how to get in there, that's all up in Discord, right? All right. Guys, I'm going to leave this. I'll leave this file system running. I'll come back and I'll do file systems when we go next. But I'm gonna take a break real quick. So break. Oh, whoops, hourglass. Pull my hourglass. Whoops. I did not mean to do that. Let me get my hourglass up. And I will turn my camera off for a second. Move this up and I'll say right here. Take a break and do some Linux. And I'll take 10-minute break. You guys can hang out, talk amongst yourselves, join the Discord, do whatever you want, and that thing will keep running on the right there. Then we'll come back and do some more Linux. All right, I'll be back. Go text the wife here in a second. Alright guys, I'm walking around stretching my legs. You should do that too. Well, you don't have to. You do whatever you want. But I'm going to be walking around a little bit. I'll be back. You guys behave yourselves on the stream here. All right, we're almost done with our break. I was hanging out in the other room, sitting on my couch in my bedroom. All right. Did I miss anything? Doesn't look like it. Yeah, nothing going on. All right. So let's get rid of this. Well, we'll squish this down a little bit. I'll come back. Pop on screen. Boom. I'm back. All right. Give that another minute. We'll let that time run out because it's the same thing I run into with my college students where like I will jump back from like a break or something. I'll just go into stuff and I'm like, wait. Maybe they were taking their break. Maybe they were getting their coffee, whatever. Like I gotta be fair, right? So, well, wait a minute. We can just talk about something else for a second. I could back this back up here. Back to the file system topics, and then we'll go through file system topics while we're kind of hanging out. But a lot of these things that they're just simple questions that we ask. Another way you could get these, by the way, if you were like, hey, where would I find all of these links? We have the courses. All the courses are free, guys. They're all. Here's our ProLUG security course. Here's our Linux administration course. They're all free. They're all online. This is all the information here. You can come here. You can see all the labs and stuff. And for any unit, like if you were on unit 15, the guys did a really good job putting these all together. I didn't do any of this. I just put together. I basically just talked through it, and then they put all this stuff up online for you. But like the worksheet has the actual, as I was showing you guys, whatever was in unit 15 and doing the presentation, and then down here you get to all this different stuff, and then you get to the lab. Oh, there was no lab for this one. You just had to work on the projects, but the outline is all here. So if you were like, what were we doing for each of those whatever weeks? Here it is. Here's the course syllabus. So I built syllabus for each of these, and these are the things that you were doing in the Linux admin course. Like, what does it take to be a Linux administrator? What do you need to know? What kind of skills do I think that you should have and kind of build to work in that role? You got to get into command line. You got to know how Bash works. You got to know how your disk storage works, and then operating the running systems. You need to know the basics of security, a little more with security on firewalls, and then patching, right? And just this was things that you need to know as a Linux guy. If you're gonna be a Linux person for a company, these are the things. So that's all there. There's a security engineering one, which digs heavily down into security engineering topics. So building servers correctly, adding them to the network, giving users access, doing it remotely with bastions and air gaps, patching, parsing. There's all these things as well. And then we're currently in this one, and tomorrow will be. Are we up to? So I'm gonna finish cleaning up these ones. So 6 hasn't been recorded. 8 has been done. So 8 and 6 are done. I didn't finish 7, but I'm gonna have all the way up probably through here done tomorrow for the when we do the class. So we'll do all the way probably 8 and 9. So it'll be 7 and 9 really happening tomorrow. But maybe I'll just take the time to just walk through everything. We'll just talk about everything tomorrow for people. But this is what the course looks like, and then we're going to get into hardening Linux systems, which we have quite a few labs on that already. So really, it's just going to be talking through and looking at like what it means to harden, because we harden on the build, but then we also harden as the system operates. There's things that have to change and go, which kind of gets into patching, right? We update and patch systems, move them forward. But not everybody wants to do that anymore nowadays. Sometimes we have stateless nodes and all this other stuff. Network, we're going to pop on, probably get a network device or two set up. Remediating and reporting on drift. That's very important, because when things change in a network or in a system without you knowing, it's a problem. And then we'll do some CI/CD pipelines, which actually have been part of these. But then we'll do that, and we're going to talk about the make versus buy versus adopt decisions and why that matters. And then we're just going to do a bunch of broken stuff, which hopefully you guys have seen a bunch of broken stuff by the last 2 weeks anyways. All right, anyways, where are we at? Excuse me, we're back from break. So file system topics. Can you show me all the free space in the root partition? Do I even know what a root partition is to be able to even talk about that? Well, a few ways to do that. We can do df-h. We can see the root mounted right here. We can see that it's mounted tempfs, which is probably kind of strange to most of you. If you're used to looking at Linux boxes, you're much more used to looking at them like this, right? And you see that root is mapped off of dev mapper rl root. And when this server goes down and comes back up, he's got a persistent, what we call non-volatile RAM of his root system, right? His root, his kernel, all that. Well, kernels are in boot, but everything about the system is there, right? But over here on this box, it's a little bit different, but could I see how much is available? 5.8 gigs. That's how much space I have available. And then maybe LSBLK-F would show me if I had any file systems or what was mounted. Now, none of these things that I have on this box are mounted, so none of this is applicable to answer this question. In my other system here, this is applicable because root is right here, and we have 45% of it used with about 55% unused, right? So can I show all of the use space? Yes, I can, right? Then another question that comes up, right? But we'll let that just roll through, because that's going to roll through every 3 minutes or so. It moves to the next question. So also, the wife's coming home, so I only have a little bit longer. But on the Twitch side, I will give you guys this. There's the Discord. You guys are welcome to join that anytime you want. Almost 40. What did I say earlier? I think it's almost 4,400 people. I think it says across the bottom too. I think I got like a little scrolling thing or something. That's the whole reason I go live, is to tell you guys about the Discord, place to hang out. People are talking down there. People are sharing decorations and all kinds of stuff going on. But yeah, our main goal is going across the bottom there. We want to get people that do this stuff for fun, or, you know, want to find a way to bridge the gap and get over into doing it professionally. We want to show you guys how to do that. So, all right. Yeah, the wife said she's leaving Target right now, so she's heading home. All right, so can you show me all of the used inodes in the root partition? Yeah, I can. But do I know what inodes are? This is a good question. Hey, Haku, hopefully this stuff's useful to you. When we look at this, right? So I just brought up a new thing, inodes, right? You were just going through and doing file system stuff, and somebody said the word inodes. Now you might think to yourself, well, okay, he did the command, he did the thing, I see him, okay, good. I see that I'm not using a lot of them, good. And that, at a surface level, might be the most interesting thing to you for today. You pick that one thing up, you'd never heard of inodes, and you go about your day. It's fine. It's probably fine for most, like, level 1 Linux engineers, or Linux admins. Like, I don't really need to know what's going on with inodes. But when you tell me you want to move up, and you tell me you want to be, I don't want to be an admin anymore, I want to go, because I see that the engineers make more money, I want to go be an engineer. Now I do need to know what those things are, and I do need to understand the implications of them. And I need to understand why different file systems I'm using may have more or less inodes, and how some file systems can expand their number of inodes and other ones can't. Why is that relatable? Why is that important? What's the trade-off when I take more? Because I used to have to expand inodes all the time in GPFS, which is the Global Parallel File System, right? Or is it General? I think it's General Parallel File System. I think it's... Anyways, it's from IBM. Big online storage system, and then we would have to up the inodes all the time. Not all the time, but like 3 times in working in that system, because we were running out of things. But what's the trade-off? There is a trade-off. We lose some storage space to get more inode space. But what does that mean? Like, you're like, well, what the hell's an inode? You haven't even told us yet. Well, inodes are places that memory can be stored, right? They're memory storage locations in a file system. So for people that have been here before and heard me explain it like this, I kind of need you to have gone to a library. If you've never gone to a library in your life, then I've got nothing for you. But if you've ever been to a library in your life, especially, you know, in the last greater than 20 years ago, we used to have a system where when we go to the library, we wanted to look up books that were interesting to us. So we would go to a thing called the card catalog. And the card catalog was like an index at the front of the library where everything could be found. And you could go look up, especially if you knew an author or you knew a subject, you could go look up things there, and it would reference where on the shelves the different books were. That's what a card catalog did. And that is very much what the inodes are like. In that, they are references to where memory is stored on the system. If you run out of them, like if I do a df-h on root, and I do a df-i on root, and this has actually happened to me before in my career, and you have storage space available, you have space out on the library shelves for library books, but you don't have a way to address to tell the system to get to those library shelves, your system's still busted. So the implication, because somebody might ask, well, what's the implication? Always sunny in Philadelphia. What's the implication? Either one of these filling up is just equally as bad. Equally as bad. Mainly with inodes filling up, you can't make any new, you can't store any new memory or any new storage, right? You have no addressable spaces. And here, you have to have the space that has been addressed, right? So either one of them is terrible to fill up. And you can keep track of both of them. In fact, most modern dashboards keep track of both anyways. I've only ever filled these up on big storage systems, big SAN, what we call parallel file systems. So GPFS, Lustre, Weka. Weka is a file system that does that, or that you might have to consider it on. All right. I mean, could we fill it up right now? Absolutely. We could do anything we want. We see how many inodes are free. We just have to make 931,610 total things. Could we do that? Absolutely. Wouldn't take a loop too long to do that. Could we see them being used? Absolutely, we could see them being used, right? I can just... right? df-h here to make sure that I'm on the root file system still. And I could just say... I could do this a few ways. I can just say touch file, and then I can say 1.10,000, right? It would make them all. And then I could just do df-i dot on this file system, and I would see that I have 10,000 less free right there. Of my 931,000, I have 10,000 less free right now. And this is the thing I tell you guys often, like when you're doing Socratic Linux, when you're asking yourselves questions and thinking through stuff, really all you're doing then is going, okay, well, okay, I know that's true because Scott just said it's true, but knowing that I said it was true is probably going to be very, very low on your things to remember for the day. But if you can go prove it to yourself, you can like go touch it at the command line a little bit, you'll probably remember that forever. Most of you, I mean, if you're a Linux person, want to do Linux, probably look at that and go, yeah, I understand what he was doing. Well, yeah, that works for me. There you go. All right. So, how far away is the wife? All right, I got to get off here soon. But, again, all the stuff I'm showing you guys, it's on old recordings, but it's not, I don't have it well organized. One of these days, I will just put together a Socratic Linux thing, and we will just do it. It'll be like 6 hours of all of these questions. We have all these questions just sitting here. A whole bunch of them. They are, you can find them if you're like, well, where are they? Well, they're up in the Discord. 2, I wanted to show you guys they're here. So if you're like, where are they? Where are they more local? Well, I know in the I know they put it at the bottom of this. So Socratic Linux, I know the guys put it here. So if you needed all of them, they're right here. But it does take a long time to go through them because obviously we're talking to stuff. But and we'll update it one day. But if anybody needs this, if you're like, hey, where could I go and dig more into this? And there's always the Discord. You guys can always ask questions there. I mean, we got people talking. There's people talking the whole time I've been on here. We probably had about 100 messages in our Discord just since I started this stream. So, it's not the most popular Discord, but it's one that's there to help people out and get better at doing this stuff. So, we're not gonna hammer you for asking questions about getting into the systems world. We might tell you to go read the field manual on some things, but for the most part, we're going to tell you, hey, get in here and do this stuff. And I think we have a good amount of people that are interested in there in getting you guys doing this stuff professionally. So, again, some of you guys have heard me get on my soapbox about that a lot. So you're probably tired of hearing about it. But for the rest of you guys, if you haven't ever been down there, it's fine. And if you don't like Discord, I can't help you if you don't like Discord. You can just hang out with me here, I guess. But I think Discord's a fine tool for what we use it for, and it's free, so that's pretty cool. All right, I will probably go then to my little end of stream here. I appreciate everybody coming by. Again, hang out down there, ask me questions. I'm literally always on the Discord, right? Like I'm always around my phone or something that we can access stuff. All this stuff, I've made it as free as possible, and the goal again to just make the path to getting into this space a little cheaper and easier than the way it is. Hi Haku, you said, do I have any materials or advice on transitioning from help desk to Linux system? I mean, yeah, I think I try to make everything that I have available to you guys. The link that I just posted right above your comment, I think that's probably one of the best ways to make that jump. Hanging out in the Discord and asking people questions, looking for jobs, all that kind of stuff, probably all something that hopefully is valuable for you guys as well. So, all right, I'm going to drop off of here, but I appreciate you guys coming by.